The scientific revolution starts now.
The Dissident podcast.
Let us see in the dark.
Now that would have been good homework for you because Huberman was not the controller. It was Rick Rubin who was the controller. It was on his podcast.
Interesting. Rick Rubin, the producer?
Yeah, he's one of my clients.
Interesting. Yeah,
and
he's done some great stuff.
And he, how shall we say, moderated between me and Huberman because Huberman is centralized science and I'm decentralized science. I have a lot of problems with many of the things that Huberman has put out there. I have a lot of problems with his perspective on science. He is wholly centralized and doesn't realize what decentralization means, what proof of work means, how it fundamentally ties you back to the fabric of nature. So
can you define those terms for us? Because I'm not totally familiar with them.
And maybe if you could, basically, if you could lay out the way that you see Huberman's position. And the way
decentralized and centralized.
Well, I think his position is exactly what you two just said. The reason you left science was because all the most interesting things weren't being linked back to nature. What are the only two decentralized networks in the world? One is nature, the other one is Bitcoin. One is fake, one is real. One is man-made, one is not. So then the question becomes, okay, what does decentralized mean? It means fundamentally at its core, it's based on a proof of work methodology. In other words, it's based on a meritocracy. What's the meritocracy in nature? Light and dark cycles. There is no central controller. What does Huberman and every other scientist, clinician who's trained in the last 150 years believes? They believe that there's a central controller. In the United States, this is pretty simple since we control Western science. It's who pays for the studies being done, whether that's the NIH or the corporations behind it. And through that, there is no meritocracy because they control the methodology. The methodology dictates how the experiment unfolds. The incentives dictate the outcomes. That's what centralization is all about. Decentralization is actually goes all the way back to Heisenberg's uncertainty principle. Everything is based on probabilities. There is no cause and effect. The only time you can have cause and effect is actually in a world dominated by Newtonian physics, where time is absolute. In 1905, we found out that time wasn't absolute through both special and general relativity. So when you consider that centralized science still works in a Newtonian platform because they believe in cause and effect, that's the reason why they use the randomized controlled clinical trial modicum to study things. You have to start to say to yourself, well, if that paradigm was good when the paradigm was changed by, Rockefeller, the Flexner Report, 1911 to 1913, and we're still using that, why are we still doing that? It's because there's a central controller behind the things in science, which brings me straight forward to 2023 and why you two decided to leave science. You don't even realize the reason why you really left, why the questions weren't being answered, because you're in a centralized platform. Some people would call that the matrix. Quantum biology is not the matrix. Quantum biology is actually the fabric of reality, and we are all threads in that fabric. And when you realize what controls the fabric of nature is light, water, and magnetism, and you start at that level of your understanding and perspective, all of a sudden, the things that have flummoxed you two and why you left begin to make a lot more sense. Why? Because you have to have the fundamental understanding that the way you understand most things was taught to you in an incorrect fashion.
Okay,
that was Rick's goal. That's what Rick's goal was in the podcast, is to make Huberman realize what he was missing.
Did he realize it?
Oh yeah. I mean, look, you have to realize this podcast, you guys know, you're podcasters. Most podcasts go on for about an hour or two. This went on for 10 hours. When it came out, it came out in two formats. Rick had trim it down because there was a lot of controversial things spoken about. But the first part 1 on Tetragrammaton was 4 hours. The second part was 3 hours. 3 hours hit the editing flaw, not because the stuff wasn't good. It's because, let's just put it this way, a lot of people weren't ready for what the implications of what were said in that podcast. And then at the end of it, the way it was left was, I need time to assimilate everything you just told me, Jack. And then I'm going to have you back on my podcast because it is very clear that I'm missing a lot of the foundational pieces, things that you've told me here that I didn't even know were published, that I didn't even know were true. And if they are true, it changes the way, you look at everything. And you have to remember, what does he do? He's at Stanford University. He's in the Department of Neurosurgery and Ophthalmology as a joint appointment. I'm a neurosurgeon. So he knows he's not dealing with somebody who doesn't know what they're talking about. And the problem is, he's got a lot of friends who do what I do, but he does not have a grasp of the science that I have. And he got a really big flavor of that. He got a big flavor of it on Twitter because a lot of people have wanted to see us two clash. And in the end, it wasn't so much of a clash. It was kind of an awakening for him that the thing that he studied his whole life, he's missed a whole other world. And it wasn't because he was a stupid guy. It's because the USB upload that he got was the same USB upload that I got. But the difference was 20 years ago, I started to question the USB upload. I started to ask questions that were better than the centralized paradigm could handle, and started to put all this together, and then did something decentralized myself. I put all my information for free, open source on the internet, and said, look, this is what I found. If I'm wrong, I've got good company. I've got Einstein, nature, the basic laws of the universe that are behind me. And if they're wrong, I'm okay being wrong, but come get me.
So let's unpack the specifics of your theory. So you say that it's a decentralized.
Let's be clear, it's not my theory. This is the way nature works. I want you to be very accurate in what you say here, because this is important. You only absorb light through the photoelectric effect. Electrons are the key. That is not my law. That is not Einstein's law. That's the way nature works. So start there first.
Okay, let's unpack that. What do you mean by you only absorb photons through the photoelectric effect? Meaning that you lose...
What's the photoelectric effect say?
Well, the photoelectric effect says that when you hit a piece of material with light of a certain frequency, it'll give off a certain amount of electrons, whatever that means.
Correct. But it's the only way that a system can absorb electrons. In other words, photons excite electrons. This is a fundamental part of quantum mechanics. So when you understand that very basis, and then you come to the next basis, which is what Huberman didn't understand, is that all living things on this planet, whether it's plant, animal, bacteria, archaea, or eukarya, have all been shown to release ultra weak UV light. Ask yourself a question: what is life fundamentally doing at that level? And then ask yourself another question: if you were never taught that in a basic biology book, ask yourself why.
I mean, this is something we've thought a ton about, actually, especially because if you look at heme, right, it bears a striking resemblance to the I believe it's chlorophyll, right? They're very antenna-like molecules, and actually, light is something we spend.
Let's be accurate. Again, you're going to find me to be a real pain in the ass.
Right on.
When we talk about stuff like this, they are semiconductors. Okay, they are both semiconductive proteins. What's the main difference? Both of them are in a nitride cage. Okay, same type of bonding structure. The difference is chlorophyll has magnesium and hemoglobin has iron. What's the difference? 12 electrons. The difference between the first two domains of life and the second two domain, or I should say the last domain of life, which is the eukaryotes that occurred, after the Cambrian explosion, that's 12 electrons. That's the difference between simple and complex life. That's what was laid out in the Huberman podcast. And I explained to him that hemoglobin and chlorophyll were the two main semiconductors that life used prior to the Cambrian explosion. And then after the Cambrian explosion, which was 650 million years ago, a third semiconductor showed up very, very quickly and kind of became the dominant player. And this has fallen completely by centralized science. And that chemical is melanin.
All right, hold on one second. Can we back this up a little bit?
I also want to say that it appears that eukaryotes existed before the Cambrian explosion by like 200 million years.
All right, be that as it may, what's the role, right? So obviously in plants, light is essentially driving the metabolism of plants, right? But in animals, we don't really think about it that way. Why not? And what do you propose is the role of light with respect to hemoglobin?
Well, that's what I just tried to lay out to you. Melanin is the reason why. You don't realize that human photosynthesis, actually all animal photosynthesis, is driven by melanin. So it raises the point that I made to Huberman, tell me what you know about melanin. And the irony was, and I'm rehashing this for you guys because I don't know if you know his history. In his lab, what does he have in a tank? He has cuttlefish or cephalopods. He didn't even know that cephalopods were innovated about 50 million years after the Cambrian explosion. He also forgot that when cephalopods are attacked, what do they release? They release ink. What is the ink made out of? 70% melanin. And what did I tell him? That human brain 1.0 is actually what a cephalopod is. And that's the reason why you see all the light that they emit. But yet, me as a brain surgeon, when I opens up somebody's head, I don't see the cephalopod inside us do that. So you have to understand there's been a lot of evolutionary changes that have happened over 500 million years. And a lot of it goes back to this original story between these three key semiconductors and where they came from, what they do, how they work photoelectrically, and where they go. And the biggest irony of the case is when I found out, and I didn't know this until the podcast went live, is that Huberman's dad is a condensed matter physicist. It turns out that condensed matter physicists now are really studying the three versions of melanin that we know are present in the animal kingdom. And the reason why is they do not understand why it works. So I want to take you back to the first thing you two said in the podcast. Why are all the most interesting questions at the edge of science? I just give you a big clue why. Because most people have no earthly idea how melanin links to the story of chlorophyll, and then how it links to the hemoglobin story, and how it ties to the story of evolution, how it links to the Cambrian explosion, how the two first domains came together to form mitochondria, and do the things that it does. And when you see the story from 3.8 billion years, let's say all the way up to the KT event, which was 65 million years, that takes most of evolutionary biology that you learn in a centralized system and completely casts it in a new light. But where it really gets interesting is when you think about the age of mammals and what it took over from, and what was the dominant semiconductor protein that actually did most of those changes. It turns out it's through a gene called POMC that makes alpha MSH, that makes what chemical? Melanin. That's what the whole story was about. It's about light and understanding how light sculpts biology.
I still am not clear what the role of this system is in the human body.
Well, I mean, again, I would love to elucidate and teach you biology in a podcast, but it's not appropriate to do. You have to
Hold on. We both have we both have PhDs in biology.
Okay, great. That
So
still doesn't matter.
no, I
Still
understand, but what I'm saying is
Still
that like
doesn't matter to me, but
hold
tell
on.
me what you
We
know
have
about
to-
melanin.
Well, I mean, melanin is a planar ringed molecule that is produced by melanocytes that live in the skin, and it, as far as I can tell, is likely protective against DNA damage because it acts as an antenna that absorbs light.
Correct. So that you learned everything that centralized science have taught you. Where's the dominant place in humans that melanin is found? You're a biologist with a PhD. Tell me.
I mean, I study bacteria, so not humans, so like cut me
Okay.
some slack.
I studied the mechanics of water, so leave me alone.
Okay, so
Actually,
where...
inside your brain.
Interesting. Okay.
Yeah, of course, it's interesting because guess what? That's why I told you you need to listen to the podcast. You want to solve
Well,
the
we haven't
biggest.
listened to the podcast.
Yeah,
We're
it's
here
unlikely that I'm
today.
going to listen to a Huberman podcast anytime soon.
Oh, well, it's a Rick Rubin podcast.
Oh, it's the Rick Rubin podcast. My bad.
Right. It's not the Huberman podcast. It's actually
This is actually interesting because the Huberman podcast is something that I really struggle with. I have a lot of friends that really love it, but to me, it feels like somebody's reading me a biochemistry textbook, and I've never enjoyed. I'm a biochemist by training, and I have a terribly difficult time listening to just molecular interaction after molecular interaction because I feel like that doesn't tell you the larger story. And so
correct.
we're coming at this not from a skeptical perspective. We're just coming at this from the perspective of light is obviously important. There's obviously stuff that's happening in the body that is both light controlled and electrical. And there's clearly a lack of study of those areas. And so what we want to do is we just want to understand what the details of the model are. Because if we can understand the details of the model, then we can go out into the world and we can plug it into everything that we do. And when we find pieces of data or stories or
Conversations
events
with
or
other
conversations with other people that like fit into it, then we can fold it in. And so this isn't us trying to tell you that we think that you're wrong or arguing with you. We're literally just coming at it from the perspective
I'm not
of like,
taking it. I'm not taking it that way, and I think that you need to understand what I'm trying to give you a background because you don't know, and I'm trying to show you the parts of science that you didn't learn that actually turn out to be really important to understanding why melanin is the critical part. I can easily elucidate for you why melanin is important. It creates hydrogen and electrons and oxygen. That's what it fundamentally does in the cell. You mentioned literally 30 seconds ago that light is clearly important, so is electricity. Stop for a moment and realize that light is electricity. And I just described to you how a cell makes a DC electric current by charge separating water, utilizing melanin to do so.
light
Okay?
is only, hold on. So light, when you say that light is electricity, can we unpack that just for a second? Because
Sure.
a current in a wire,
But that's not the way you think about it.
what do you
That's
mean?
the way you think about it. What is electricity fundamentally? It's the electric force, which is part of the electromagnetic force. What is the force carrier of the electromagnetic force?
I mean, you can't start an explanation with a force. That doesn't really. That's like saying that an action is that actor. You know, I think you got to think that electricity is something that atoms are doing to each other
is
in a
motion of some
conductor.
kind.
Yeah, some kind of motion.
You guys are allowed to think whatever you want. You ask me a question, I'm telling you the answer.
No, we're just trying to
There's two
understand. It's like we
forces.
don't understand yet. And so like
Right.
when
So let me try to make this simple. The force carrier for the electromagnetic force is a photon. That's light. Okay. So light
it transmits.
liberates,
It transmits.
light liberates electrons from water. Okay, the same thing, same story that happens in photosynthesis. Okay, except it's much more efficient when melanin's involved. Okay, in photosynthesis, only 2 electrons are popped out. In melanin biology, 4 electrons are popped out, plus more hydrogen is made. So you make a bigger electric current. The story that I was trying to lay out to you last time before everybody jumped in is the difference between hemoglobin and chlorophyll is 12 electrons. Okay. That's the difference between simple and complex life. Turns out that melanin made more complex life even more complex because it allowed more energy production inside the cell after the Cambrian explosion. Therefore, the things that we should see in life as we go further along, say, the history of evolution, is we should see higher levels of redox chemistry. We should also see higher levels of DC electric current. We should see increased utilization of light in much more complex fashions, meaning nonlinear optics should be a part of the system. And then the question becomes, do we in fact see that when we move, say, from archaea all the way through eukaryotes, and they go from eukaryotes, from the base ones, which would probably be fungi, through cephalopods, all the way through primates? The answer is yes. These were fundamental questions brought up by Rick to Huberman when he had no fundamental understanding of this. The issue became, I needed to explain to him certain experiments that were done early in the 20th century that were not published in your biochemistry books, that were not published, in fact, in any books, because they broke the paradigm of the people who built Western medicine. It did not allow them to control the narratives that they needed controlled. Therefore, hitherto and moreover, the things that we've all learned, that means you guys in your science background, me when I was getting my degree, Huberman the same way with his PhD, we all have a commonality. We've all learned a lot of the same things. The difference between all of us right now is where we stopped.
But hold on. It's still not clear what exactly we're talking about here, because so I actually, when I did my studies, I studied metabolism in bacteria, right? I actually studied the electron transport chain. I studied redox. The project that I was doing is we were looking at these little molecules called phenazines, and the phenazines were produced by the bacteria, and they're redox sensitive, and so they get shuttled around the biofilm, and depending on their redox state, they activate different genetic programs, and so they act as this proxy for multicellularity in a single-celled organism, because you have this long-range communication of states and information carrying. Okay, so it's been a while.
And there was a girl in your lab who was light cycling them and finding interesting phenazine output.
She was Lisa Kahl. She was finding circadian rhythms and different phenazine productions depending on light. So like this is in the realm of stuff that I was exploring. And so what I'm trying to understand is most of metabolism occurs at the membrane of a mitochondrion in a eukaryote. It's at the membrane for a bacteria. Okay. So when you're saying that melanin is involved in energy production, I have a decent understanding of the way that, let's say, the chloroplast and chlorophyll is involved in the production of ATP. I have a decent understanding of the way that the electron transport chain works to produce ATP, which is then used elsewhere in the cell to catalyze reactions. How does melanin fit into this picture specifically?
It's several levels proximal to this. The dominant belief in biology is what you just stated, that ATP is the dominant energy carrier inside a cell. That paradigm was challenged by a guy named Gilbert Ling, also a PhD in biology in the 1950s.
I've been meaning to read Gilbert Ling's book. It's on the shelf. It's like next.
That's one of the big problems with centralized biology people, is that they don't get told to read guys who started to do some of the decentralized work. But who predated Gilbert Ling? Someone I think that both of you will know. It's a guy named Albert Szent-Györgyi, the guy that actually won a Nobel Prize for both vitamin C and his work in and around the TCA cycle, even though he was not correct about the TCA cycle, and that had to be fixed later in 1954. One of the most interesting things that he said about dealing with the substrates in metabolism that are inside the mitochondria is that he noticed that they all have an electronic structure. And he was the first person in centralized science that actually bucked the system. And he gave a very famous talk that I relayed to both Rick and Huberman in 1941 after he had won his Nobel in 37, where he told a bunch of medical students that he felt that biochemistry was not the key story. And remember, this guy basically won the Nobel Prize for biochemistry. He said there's clearly another layer of, I don't want to say power, because that's not a fair way to characterize it. There's another way to control biochemistry that we haven't laid out, but in his mind, he felt that it was based on solid state physics. Why? Because all proteins that are coded for by DNA all seem to have a structure that looks like a semiconductor. He was the first.
Hold on, explain that. What do you mean by that?
Well, I can't tell you what he meant by it.
No,
I
what
know,
do you mean by that? Like you repeat it, so you must have a mental picture of what that means. I don't know what it, because like I also did.
They're made of
carbon-based. I did protein
They're made of
crystallography,
carbon-based hydrated semiconductors.
I don't know what that means. What does that mean? I don't know what a semiconductor is. Explain it to me like I'm.
Semiconductor is anything in the world that's hit by light that releases light of a different frequency. Whose work defined that? A guy named Bose back in 1895.
So what you're basically saying is that all proteins are fluorescent.
No, I'm not saying that at all.
What
I'm saying semiconductors.
The way that you defined it is that, hold on, if you define semiconductor as something that is hit by light and releases light, that's also fluorescence.
Correct. It also releases electrons. They get delocalized. That's exactly what a semiconductor was understood to be in 1937, again in 1941, and it's still the case now. The problem is the guys that are in Silicon Valley right now, that are the experts in semiconductor, what are they experts in? They're experts in silicon-based ones.
Sure.
Okay. They're not experts in carbon-based ones. In fact, they believe when you put silicon in water, it basically makes your iPhone go boom. It turns out that 3.8 billion years ago, Mother Nature, through her decentralized magic, figured out that carbon is a smaller atom on the periodic table, and that it has huge advantages to be used as a semiconductor. It turns out it happens to be a semiconductor when it's not hydrated. So let's talk about a crystalline structure made out of carbon that you very much know. It's called a diamond. And a diamond actually releases 10,000 times more energy than a silicon-based semiconductor. In fact, it has something called a band gap in it. That's how they categorize semiconductors. Well, it turns out that carbon-based semiconductors have wider band gaps than those made out of silicon. Now, that's never actually been studied at all by biology. But the person who realized it first was a centralized biologist from Hungary named Albert Szent-Györgyi. And he told a bunch of medical students that he felt that this was the key to understanding the cycle and the vitamin C that he discovered in 37, that he felt it needed further study. And he spent the rest of his life actually trying to motivate young students to that endeavor. Turns out in 1941, there was one young student in the audience who actually paid attention to Albert Szent-Györgyi. His name was Robert O. Becker. He was in medical school at the time, and he was fascinated by this talk. So what did he decide to do? He went through training, learned all the same things that I learned, eventually was a smart guy, became an orthopedic surgeon, graduated, got an appointment after he was through at residency, and worked in the SUNY system as in academia. And he then began to work on limb regeneration as an orthopedic surgeon. And at the time, what was going on in the 1950s was the Korean War. And there was people coming back from World War II. And we were getting ready to get involved in Vietnam. So one of the people that he petitioned to fund his work was the US government. And his goal was to work on limb regeneration to try to save the VA system a lot of money with prosthetics and things like that with injured soldiers coming back. Through Becker's work in the late 50s and early 60s, he used some seminal work that he learned about that I relayed to Rick and Huberman about semiconduction in different systems. He began to test his theories in the lab, and he was the person that definitively showed in 1963 that bone works completely by semiconduction. In other words, collagen, which the structure, 3 carbon or 3 amino acid chain, a triple helix, was piezoelectric, flexoelectric, actually had semiconductive properties. He found that it was a P-type semiconductor. He then found through his experiments that apatite, which was the mineral associated with collagen in all the different levels of bone, was the N-type semiconductor. He also then found out that the current between the two semiconductors was rectified by 2 copper atoms that were electrostatically bound in the structure of bone, and those rectify the current, meaning that the current only went one way. Why was that important? Because if you understand solid state physics, basically he explained why orthopedic surgeons and neurosurgeons don't see light emitted from diodes when we cut into bone. It's because the current is rectified. And he proved this all in a beautiful set of experiments through the late 1950s and 1963. These were things that I never learned in medical school. In fact, I only learned about them in the 80s and 90s when my program director in neurosurgery told me about Becker's work and asked me to do a report to the other residents on how bone heals. And he's the person that actually told me for the first time in my life that bone doesn't heal, it actually regenerates. And Becker was the one that proved that it regenerated, explained exactly how it happens, that we take red blood cells in an injury blastema and it de-differentiates and replaces the bone wholly. That's the reason why when we go in and do a craniotomy on somebody or we do an operation on their bone, there's never a scar, because bone is one of the tissues in eukaryotes that are mammals, that are humans, far down the evolutionary chain, that we have that ability of complete regeneration present. That was the whole goal of Becker's line of work. He started off initially with salamanders. Salamanders have an unbelievable ability to regenerate. You can cut the brain out and they can regenerate the whole brain. You can cut the heart out, they'll regenerate the whole heart. Obviously, that doesn't occur in us. Becker was able to elucidate through his experiments why it doesn't happen in us, because of some complexities that are unique to the silly talking monkeys and not other branches of evolution. Where everything went off the rails, the reason that you two don't know about this work, the reason Huberman doesn't know about the work, the reason I didn't learn the work in medical school is the military, the industrial military complex was funded his research, was very, very interested in what he found, because they then believed that he could regenerate tissues. And one of the things that he did right that's still accurate to this day, he did prove that the one thing that we can completely regenerate is the tips of fingers in soldiers that have had them blown off. That we still have the capability to do, but we can't regenerate a limb from a stub. And he showed why. The military then decided.
Do you know why?
Yeah, it's not important though for this story. And this is stuff I'm giving you historical perspectives now, so you can go back and read the papers, because in my opinion, I can easily give you the history. You need to go back and learn this stuff for the first time and then say, Jesus, the implications of this work are unbelievable, because it is.
But I
like actually one of our associates, do you know Michael Levin at Tufts? He seems to be working on this regenerative process, and he is looking at the group signaling and the electrical behavior.
I like that you call him our associate.
He's been on the show a couple times. He's we email. I wouldn't go so far as to say we're friends, but we're associates.
I love that. Yeah,
well,
and we had. Do you know Michael Claridge?
No, I don't. But I was going to say, you'd have a discussion with some of the scientists today that are working on it to find out how much about Becker's work you'll know, or they know, And I think that will stimulate another, how shall we say, mushroom cloud for you, because this part of the story I want to get to.
Okay.
No interruption.
Actually, can I?
I mean,
no. Oh, hold on. If I'm not going to interrupt you, could we take a break so I can use the bathroom? I'm sorry.
Sure.
I
No
have the
problem.
bladder the size of a thimble. If you are enjoying the Demystify Sci podcast and you want to find a way to support us, then come on over to patreon.com/demystifysci. You can give us a couple dollars a month, and in return, we will give you both of our week's episode early on Saturday morning, maybe sometimes Saturday afternoon. And you get to join our Sunday weekly patron chats, where we get together with the community and we figure out where we're going to go, where we've been, and what is most interesting in the world. If you cannot do that because you do not have any spare cash right now, that is totally fine. You can leave a comment on YouTube. You can subscribe to our podcast. You can leave a review on Spotify or Apple Podcasts. Or, most importantly, you can just tell a friend, because word of mouth is the way that we grow. And so if you have a favorite episode, go send it to one of your friends who might enjoy it. And if you've already done that and you are still casting about, then consider booking off April 6th and 7th of 2024, when we are going to have our very first conference, where we will gather everybody who listens to the podcast in Austin, Texas, to talk about the greatest ideas that are coming to the world. In the meantime, enjoy the conversation with Jack Kruse.
Turns out that the initial impetus is actually via the photoelectric effect. What did he find out? That ambient light from the environment was the key to the story. He found out that the current was actually below the myelin level at the injury site. That was the electric power that actually was able to de-differentiate the red blood cell in the blastema to actually regenerate the bone completely. So, of course, he wanted to find out what the frequencies of light were that caused this. And he found out that it was red-brown light that was emitted by the collagen apatite bone. He was able to characterize that. When this information was given to the Secretary of the Navy in the 60s, they asked some very good questions. They turned a lot of his work over to scientists that were working in Bethesda, and they said, you're basically telling us that biology uses light to control things inside a cell. This is new information that we didn't really have a good handle on. So they said, is it possible that light could be causing certain things in our pilots? Could we test this? Could we test this hypothesis to see if this effect had long range? So in 1967, they funded a study that was done on the Blue Angels down in Pensacola, Florida. And through the avionics in the cockpit and also the light that was in the cockpit, Becker basically showed them that triglycerides, blood glucose, and insulin levels all went up in pilots who sat around that. So then the next question the military came up with, how many other effects were present biologically? And then the big question they asked him at that time, if light can control these things inside a cell, could we use light to control our new nuclear subs that were all over the world? Because we did not have a system that could do that, especially on the other side of the world. So the military then shared some interesting data with Becker that they were building this antenna called the Sanguine antenna in Wisconsin. This is now late 60s, early 70s. They had planned to put it specifically in Wisconsin at a certain height because they said that it would cover 7/8 of the Earth based on their physicist calculations to monitor nuclear subs all over. And their question was, would this antenna have biologic effects on the people around the antenna? And what would the effects be of the seamen that were in the submarines all over? So Becker then began to do this work for the military. And lo and behold, when he finished all this in 1973, he came up with one of those really thick, information packets for them. He was invited to Congress to give testimony, closed testimony. He did that. The Secretary of the Navy at this time now had switched and was very interested. They then hired Becker and funded him to do more studies on this area because they were very interested in it. And what Becker found from that point of time is that the military was a lot less interested in the biologic effects on light on the living system. Yet all the papers that he gave them from 71 through 76 showed pretty amazing things. And when Becker was challenged with doing this, he had a gentleman in his lab who was a physicist, a biophysicist named Andrew Marino. Marino helped him do all of his experiments. One of the key experiments that were done in 74 and 75, this was after published papers had come out that showed that environmental EMF was linked to leukemias and lymphomas in children in buildings that were in Denver, Colorado. It was done by a scientist named Judy Wertheimer. Becker got very interested in this because he wondered what the effect would be on seamen and military personnel around these antenna arrays. So they began to do studies on this, and the effects were tremendous. So much so that Becker went out, hired Marino to do the work, and they had power lines. Where Becker's lab was in SUNY Syracuse. So they had just constructed in 1976 from New York City to Niagara Falls these 765 kilowatt towers, and Marino thought this was a good idea for the industrial military complex to see something that was local to his lab that they could test to see what the effect would be on the Earth's magnetosphere. And when they did the study in 76 and gave it to the military, they found that these small little power lines that went between New York City and Niagara Falls actually altered the Earth's magnetic sphere 80,000 kilometers above the surface. That was turned over to the government. And believe it or not, there's congressional testimony on this. You can see all this science laid out in excruciating detail because a lot of it, most of you will have a lot of difficulty finding the original papers because they've been removed by the industrial military complex. But Marino took such good records during this time, he actually went back and became a lawyer. So he was a lawyer and a biophysicist, got both degrees. And then he began to be called by the Congress about testimony about the biologic work that Becker had done. Becker became very, very frustrated with the people who paid for his research because he clearly found that light controlled and sculpts biology at a very fundamental level. He was now working out the methods that Albert Szent-Györgyi talked about in his 41 talk, and why these things were exceedingly complex, and they were not the domain of biochemistry. They were not the domain of biology. Fundamentally, biology, according to what Becker's mindset was back in the 60s and 70s, biology is not a fundamental science. Physics is. And actually, everything in biology is solid state physics. That's kind of what Becker found. And that was shocking to him because remember, just like me, just like you, we all come through the centralized paradigm idea that biology isn't of itself a foundational science. And what happened from this point, you can read about in Marino's book called Going Somewhere. Becker became so frustrated with the military who said they were going to do things that they never did. He went on 60 Minutes with Mike Wallace in 1977 and basically reiterated the story that I just told you, how it started, how it went, all the things that he found. And of course, the people on 60 Minutes were stunned. Just so you guys know, Becker was nominated 3 times for the Nobel Prize by the Nobel Committee. 2 weeks after the interview on 60 Minutes, his lab was defunded. His career was effectively put on ice after that. It got so bad that Marino wound up having to leave. Where did he wind up going? He went to LSU Shreveport in the Department of Orthopedics because a lot of Becker's friends in the 70s and 80s were there. Dr. Marino just retired, I believe, 4 or 5 years ago. How did I become aware of him? I trained at LSU Neurosurgery in New Orleans. That's affiliated with the Shreveport program. 2 years before.
What's the military industrial motivation to quash this research? I don't totally follow that thread.
I mean, it should be pretty obvious to you. If you think about the timeline that I try to give you in the history, we were an industrial complex from the Civil War to about 1950, when the Bell Labs guys discovered the transistor. We decided to go from an industrial economy, basically get rid of the Rust Belt, send it off to Mexico and China, and we were going to build information technology. So everything was based around solid state physics and semiconduction. The last thing that the builders of the economy wanted to hear was that there was problems related to this paradigm that needed to be studied.
Like
And
second order
Becker-
health effects, like dangers. I see.
And there was a lot of initial studies by the companies that were involved in this initially. That's Intel, Motorola, Qualcomm, who tried to bury a lot of this research because they did not want the information out. And this is way before the internet is, 2023. This is going on in the 1980s now, 1990s. It was all coalesced in the 1996 FCC law that Billy Tozen got pushed through Congress, when basically he gave the semiconductor and technology companies legal immunity, just like we have in vaccines, in that law. And most people don't understand how this story limits on. So my goal was really to explain to Huberman why he didn't understand the decentralized or the solid state physics part of the story, because basically 70 years of that was taken out of centralized science. Why? Because nobody got funded after Becker to do any of this research. If you try to do any of this research now, and believe it or not, to Huberman's credit, he actually told me that he's tried to get some funding to do some of this work because of, the issue with cephalopods and why they emit all this light, through their primitive brain. But he's found it extremely difficult to get funded that way. And the reason why is laid out in this story. Once you understand that Becker was the first scientist who actually started to get down to the brass tacks of what Albert Szent-Györgyi warned us about with biochemistry, you begin to see that everything in biology actually is controlled by the photon. And it turns out that the photons that are most important are the ones that come from the sun, meaning 250 to about 760. Terrestrial light does go up to 3,100 nanometers. That does play a role, but from about 1,000 all the way up to 3,100, that's a water story. And since you told me you're a water guy, maybe we can pick that up at a later date. But the real story...
I think there's a little hole in the radio frequency spectrum too, in the atmosphere. So we do get some really long wavelength light also.
Yeah, we do. That's tied to the Schumann resonance, but that's also part of this story that has been buried. I
think one thing that would help us is just to contextualize the harms that are potentially threatening, right? Because
I'm going to be honest with you, and I don't want to be a total ass about this, but I don't really want to get into that, and I'll tell you the reason why. I think that this podcast is going to do a lot for people to understand the history of why we don't know this stuff. Like, the harms are out there. Everybody can go and read about these things now. Most people do not want to believe them. Why? Because they're addicted to the technology that we now use. They don't want to learn about this stuff, but I promise.
I tried to write a blog a couple of years ago. When 5G was rolling out, I think like right before the pandemic, I was trying to make sense of this, and I was going through the literature, and it seemed like there was studies from every angle. Like there was studies that said, they try to put these high frequency radio emitters near groups of cells, and it was like all these different experiments, and it just seemed all across the results were all across the board. Some people were
let me
showing...
give you the one experiment. Let me give you the one experiment, since you're both scientists, that I know that you can find data on, and that will stun you. Okay. It's the NTP toxicity study that came out in 2017. The original, and remember who paid for this. This is the federal government again. Okay, this is the last big study that was ever done on electromagnetism that wasn't really screwed with. So the first final say came out and was published in 2015, and it freaked everybody out. Why? Because it showed that nocturnal mammals, specifically mice and rats, developed these unusual types of cancers. So when this came to the NIH was stunned at the results, and they asked the scientists to go back and really look at this closer.
Sorry, not nocturnal animals developed cancer in response to getting light
electromagnetic radiation from
night.
0G to 3G. This is these are network powers that were present and used at that time. Okay, we've now far past that. So the NTP toxicity study is published, it's out there, everybody knows about it. So when the government asked them to go back and relook at it, the final tally came out on November 1st, 2017, and it clearly showed that non-native EMF definitely has an effect in the non-thermal range. And this completely goes against the government narrative, the FCC law of 96, and most of the centralized scientists that have backed Intel, Microsoft, Qualcomm. And basically what it should have done to science is maybe we need to go back and relook at this with a new perspective. Now that never happened, but that study was out there. And we now know there is non-native EMF effects. The reason why it's important for me to tell you about the story, that's exactly what Becker was trying to do in 1977. He was trying to tell people that non-native EMF definitely has biologic effects and that we need to study this. But remember, in 1977, no one had a cell phone. No one had a microwave oven. The only people who had microwave ovens were the extremely rich. And the problem was these things were not being used in close proximity to the population. Remember the story I told you about Sanguine? It was around where the antenna was in Wisconsin, and then where the nuclear subs were on the other end. And the same thing was true with the guys in Pensacola. And there's a lot of other studies that you'll read about that Marino detailed. All of Becker's friends that started to do this work, when you read these papers, you will see the effects yourself. And I'm going to tell you, the effects are important, but I don't think they're important for this podcast because you guys are scientists. I want you to know that there's a treasure trove of stuff out there that you haven't been taught. And when you learn that, then you're going to be inquisitive enough to know to say, well, is this the reason why the French government just came out and said the iPhone 12 emits too much radiation, but yet the United States or Israel didn't come out and say that? Why is it that we got this news article that just blasted out in the last 48 hours of this podcast that's out there? Well, the reason I want to go through this history lesson with you guys is I want you to know that Becker already proved this. Okay? He proved it a long time ago. The problem is now we're using 4G, 5G, and in some cases 6G. So if you knew the effect was present in the NTP study, which basically corroborated what Becker originally found, the question becomes, why are we continuing to do this? The answer, or the inconvenient truth, is that that's what the world economy is now based on. So it's going to be really hard. It brings up the Upton Sinclair quote, it's really hard for someone to stop using something when their salary depends on it. The same thing is true when it comes to the economy. And the reason why Marino wrote the book Going Somewhere is he was trying to show his 50 years in centralized science, how it was corrupted, bought and paid for, how it was done through methodology, how good science was buried, why it was buried. And to me, this story is actually the story that needs to be heard by you two and by guys like you, Rubin. Why? Because it will force you to go back and look very carefully at what Becker found, and link it back to what Albert Szent-Györgyi said about biochemistry. And I've had the fundamental belief for most of my life, because I've lived in this time, that it may not be me that does it, but it's going to be probably a scientist that Huberman teaches at Stanford University that begins to connect all these dots and go, you know what? This is something I think I want to study. And the way in which I need to study this, I need to be smarter than the people paying for the studies. In other words, I need to use cephalopods. I need to use salamanders. I need to use humans. I need to explain the evolutionary trajectory and kind of what's happened in this control system that's controlled by the electromagnetic force. And then I need to figure out, okay, what are the safety ramifications of the system? So, for example, the reason I bring this up is because it's current events that we're going through. Don't you find it amazing that we just got the last bit of boosters for the new variants in COVID produced without any safety studies? I'm going to tell you that's the same game plan that happened between Szent-Györgyi and the iPhone 12 in that other branch of science. What people don't realize is the story is actually the same. Why? Because if you understand the original patents used in the messenger RNA technique, Dr. Malone has talked about this exclusively because he owns some of the patents. We know that the electromagnetic force controls a lot of these things. The problem is that link has not been made in the centralized science in and around what Fauci, Collins, and all the architects through the NGOs like Peter Daszak have done. And the reason we're not able to get our hands around this is we don't realize how what Szent-Györgyi said, how what Becker's already proven, all the things that Marino has collated, the things that have been told to Congress for 50 years that are now archived. You have to actually go back and look at it. I've actually tried to go back to DC to find some of the testimony of Marino, and it's redacted now. The only place you can find it is his book. And when you see the book and you see the original testimony and you read it for yourself, not as a taxpayer now, just as a scientist, it is the most curious thing in the world when you consider what's actually happened, say, from 1982 to 2023 in science today. Why? Because basically, JFK gave a great speech about 2 months before he was killed that basically said the problem in all of the world is when we censor ideas and we censor speech and we censor science. He actually specifically mentions science in there. And remember, Kennedy was involved in funding some of Becker's work, which his key papers came out in 61, 62, and 63, which is during the Kennedy administration. The people that originally funded him were actually Eisenhower and Eisenhower's administration. And these guys were very, very interested. I can tell you, the industrial military complex at the beginning of Becker's life, they were truly interested in solving big questions in biology, like the questions that you guys told me in the beginning of this podcast that you were very interested in. The problem became when you see the way the science was done and the results didn't go the way, I guess, the architects of the new economy thought they would go, how things were sculpted and shaped in a certain way, and what were the collateral effects, the butterfly effects for that, for future clinicians and future scientists. I mean, I can tell you just from my perspective, when I was a medical student and a young resident, I did not know that bone completely regenerates. I always thought bone healed. And it wasn't until my program director told me about Becker's work did I find out a whole other side of the story. And I remember
what does it mean for something to heal versus to regenerate?
Well, it means that I'll try to make this as simple as I can. When we go and do in utero surgery, say to put a shunt in a baby or cut them, when a baby comes out, it has no scar. See, when we do that surgery one day after they're born, they have scarring. Why? Because wound healing has to take effect. What Becker found out is that what controls wound healing is actually the electromagnetic force. And if you know how to apply the electromagnetic force, you can actually control regeneration. He even went so far to say that this explained probably the mechanisms of cancer and also described actually how and why things like acupuncture may work. And he actually, his last paper that he ever did was on acupuncture. The part that I was most interested in as a neurosurgeon is immediately I started to think about Parkinson's disease radically different. It made me realize right away that we put electric pulse generators into someone's brain, into their substantia nigra, where the melanin's supposed to be, to stimulate the DC electric current. We're actually stimulating something they lost. Why? Because the melanin's gone. And it got me to realize.
So in Parkinson's, do they have less melanin in the substantia nigra?
Absolutely. That's actually the fundamental cause of the disease. And when you begin to see this in diseases that we treat in centralized medicine, especially diseases that we have no answer for, it begins to bring you back to Szent-Györgyi's 1941 lecture. Begins to bring you back to some of the basic science that Becker did, because it's almost like Becker's work got amputated by the industrial military complex. And I guess the point that Rick was trying to bring out to Huberman is Huberman trains these future scientists right now. And if he knew about this historical perspective, he may be able to stimulate 1, 2, or 3 of those kids at Stanford instead of just doing straight clinical track, maybe to do an MD, PhD like Becker did, and maybe to take over and go. I mean, some of the amazing things that Becker found in his work, that when he was working with salamanders, he was actually able to anesthetize them just by putting them on a 2000 Gauss magnet. Think about the implications of that just for anesthesia alone. And the crazy part was Becker realized it, but it's kind of like he left that by the wayside because he was so focused in on figuring out how actually bone regenerates in humans. He was that tunnel vision. But when you read his work, I'm sitting there going, can you imagine if someone would have picked this up, we would now have an answer to the 200-year-old question, how does general anesthetics work?
This makes me
electromagnetic progress.
This makes me think of something that we had Clarisse Aiello on the show, who's a quantum biologist at UCLA, and she was telling us the story about a guy, I think in France, who builds these crazy Faraday cages. And he built a Faraday cage that can completely ablate the magnetic field of the Earth, which is very small. And when he grows embryos in it, I think frog embryos or zebrafish embryos, they come out deformed in the absence of the magnetic field.
They all have morphogenetic problems. Why? Because it turns out that magnetism actually controls acoustic phonons.
And so people are working on this. They're not working on it in the way that's direct. And also, I looked up the NTP study that you found, or that you mentioned. And so basically, I just want to lay it out. On the NIH's, NIH.gov, it says there's clear evidence of an association with tumors in the hearts of rats when rats are exposed to high quantities of radio frequencies, like those that come out of cell phones.
Yeah, so I guess it becomes a quantitative argument at that point. I mean, my sense is that people know this.
It does. I would argue vehemently against that because that is the surface level thinking. It's not. Remember, it's quantum mechanical. And what does quantum mechanical means? It means that there's a butterfly effect.
Well, it's a probabilistic, but probabilistic still means that you have to, the likelihood of a defect still comes down to the weight of the probability. And so if you have more, if you have a probabilistic system, then the more insults that you have on it, the greater your likelihood of a bad outcome is.
Well, then think about what you just said. You just proved my point. That was in radio frequency, which is what you both just said on the safe end of the spectrum. What's the most common non-native EMF that's used in our environment right now?
You mean like 5G?
Waves and blue light. Think about it.
I mean, my sense is that people know this stuff is kind of bad for them, but just like cars are kind of bad for you too, right? I mean, cars kill lots of people, but they're really, really convenient. And it's like, I think people feel the same way probably about radio frequency pollution too, where they're like,
I disagree with that.
I don't probably think bad for you, but nobody wants to give up their cell phone.
I think that everybody knows that their cell phone is bad for them. I don't think that they might. I don't think that they know specifically the way that it's bad for them or why it's bad for them. But I have yet to meet a person who looks at their cell phone and is like, "This makes me better." Like never, ever. And so there is some kind of visceral, deep sense of this is fucking me up. And I know that it's fucking me up, but I'm never going to quit it because I love scrolling.
Right. And it comes down to the point that I'm glad that you're both starting to see is that this comes down to medical freedom and medical consent. Like, I'll give you another part of the story that I didn't think we were going to get into, but it's important. If you go read Steve Jobs' book, his biography written by Isaacson, one of the things that he says in there He talks about the iPad 2. When it came out, they put an infrared sensor in it and they never marketed it. And the reason why is because Jobs was worried that when the body of the iPad touched the child's body, that they would be doing harm. So what did it do? It turned off the RF and microwave emission from the device. So if you continue to read on that passage in the book, it also says this is why Jobs never let his kids use his own devices. Now, I want you to think about the implications of this in light of what I just told you about Becker and Marino. Can you imagine coming up with such a novel idea and why Jobs never told anybody about it? Because it would have immediately brought the question up to both of you in the beginning of getting you addicted to technology. Why are you putting a device in here that actually limits, light pollution in and around my body? Is there something that you're not telling me? The answer is yeah. Like Jobs knew about it. And I want you to think about the crazier implications. Here's the butterfly effect. Remember that Jobs created a word in our vernacular, laptop. Why? Because he always put the laptop in his lap. And you guys remember, you're young enough to remember that when he was alive and he did his Mac shows, he always had a wore out part of his pocket for his iPod or his iPhone. What did he die from? A retroperitoneal cancer. Stop for a minute and take a look at that study from NTP 2016, 2017. That should get you to think. Like, did he know a lot more than you think? And I'm going to tell you, I can tell you personally, I know things about the big tech industry because of my connections in it, that Jobs knew exactly what Becker found. He knew exactly the reason why he put that infrared detector on it. He knew exactly what he was doing. But at the same time, he had the belief that you had, my friend, a little while ago said, well, I don't think I'm going to stop using this. Well, guess what? You might have if you would have listened to Becker in 1977.
But
I just think that it goes beyond addiction. It's like, I don't know how most people would function without those technologies at this point.
I'm going to tell you it actually starts with addiction. I'm going to explain. This is the reason why I really wish you would have listened to the podcast.
But this story tells us that Steve Jobs knew, right? So you're saying that Steve Jobs knew about Becker's work. He knew about what it was going to do, and yet he still put it in his pocket and he still did the laptop. And so that suggests...
That's what I mean is, like, everybody knows that there's a very good chance that they're going to die in a car wreck. Like, that's a pretty high contributor to mortality, especially below the age of 45. But they still drive cars and they love driving cars.
The point that I would make to you is that when you hear this story and you put it together, you should have the choice. And I think that's what your friend, your co-host is trying to say, that Steve Jobs made a choice. And you know what? I actually agree with your co-host here. But I think that his choice is highly instructive for silly talking monkeys today that actually haven't thought deeply about this. And the point that I wanted to make to you, young man, because I hope you really dive down this rabbit hole, the gene product that makes melanin is called POMC, pro-opiomelanocortin. It only gets translated or turned on by UV light, okay? So one of the peptides, the neuropeptides that's made from this, besides alpha MSH that makes melanin, you know what it's called? Beta endorphin. So you know what that means? Nature made you to be built to have a certain quantized amount of an opiate to be outside. What if I was to tell you, well, what if I was to tell you that your cell phone in your pocket could change the neuropeptide cleavage in POMC so that it would lower your dopamine levels so that you would become addicted? And what if I was to tell you that Becker knew about some of those patents that were initially owned by DARPA, okay, through the US military, that now are sitting in the vaults of Google, Microsoft, Meta? Why? Have you ever asked yourself the question why every single screen tied to a device that uses RF and microwaves always is blue lit? Well, there's a reason for that, because it lowers your dopamine level. And
I
do you know
have
where
a red light filter on all my screens.
Do you know the reason why the DARPA got this information? You'll be shocked. They got it from the Mafia in the 1940s and 50s. That's the reason why casinos don't have any lights. That's the reason why they came up with slot machines, because they're all blue lit. because the mafia found out that if you put people in blue light and fed them alcohol, you didn't have to stick a gun in their face to take their money. They would give it to you because they'd all develop Stockholm syndrome over a period of time because their dopamine levels would get lower. And guess who got that message in California? Steve Jobs. Guess who else got it? Bill Gates. Guess who else got it? Mark Zuckerberg with Facebook. Now, hearing this part of the story, maybe I'll give you a chance to rethink your position. Knowing all this, if somebody would have told your parents this, say when you were 2 years old, do you think that maybe your belief about unfettered use of technology would be different than it is right now? And the point that I'm trying to make to you is that I believe we need to have medical freedom and choice. And the only way we can do that is when we have science that's not censored.
100%. 100%.
That is really the story for me behind this podcast. The reason why I went to talk to Rick and to talk to you, Rim, the reason why I'm talking to you two is because this story is really, really important. It's really important for someone of your generation, someone who's involved in science, to say, you know what? We need to go back and check this dude out, Becker, and find out just what the implications of his work really are and see where it goes. And then it may not be you. It may be one of your friends. It may be somebody else that comes on the podcast. It may begin to explain to you why red light has such tremendous benefits for mitochondria. Why? Because sunlight always has red in it when blue's available. But guess what? Your iPhone never does. Mm-hmm. That's the whole fucking point. That's the reason.
I'm very allergic to blue light, actually. Yeah. I mean, I notice this all the time. I mean, my sense is that if we depend upon an industrially funded science infrastructure, institutional science, this is bound to be the outcome. What happened during COVID with the capture of the government is bound to happen. So I'm really interested in the solution set. Like, what does an ideal, beautiful system of science look like 200 years from now? How do we actually organize our inquiry into a way that, into a method that doesn't lend itself to capture like this? Because
I'm going to tell you,
that's where the money comes from.
I'm getting ready. Probably shouldn't tell you this, but I'm getting ready to do.
All right, so we left off and you were like, I probably shouldn't tell you this, and right. you got to tell us now.
I'm doing another podcast with Rick pretty soon, and it's going to be with someone you all know who is an environmental lawyer who knows a lot about these type of topics. And you asked me a question, what's the solution to this? If you understand the real problems that we've laid out in this podcast, the solution is a medical freedom law. Now, I'm going to have to take you back in history because you're both Americans. You should know the story of Dr. Benjamin Rush. Dr. Rush, who Rush Medical School is named after, proposed to both John Adams and to Thomas Jefferson when the Continental Congress was going on and the Federalist Papers were being written, that we needed to have laws for medical tyranny in the Constitution. But both Adams and Jefferson never thought that this was plausible based on world history up to that point and kind of what happened, in Britain, because that wasn't really a part of the story of why America broke free at the Declaration of Independence. The interesting thing is some of his writing on this topic, a lot of people don't know, was what got Thomas Paine to write Common Sense. And Common Sense was the thing that changed everything for the colonists when they decided we need to declare independence because of what he wrote. Most people don't know the history that it was Benjamin Rush's ideas around medical tyranny that stimulated Thomas Paine to write what he wrote. So the drawn out answer to your question, I believe that we need medical freedom laws. Those laws not only need to extend to the clinic, but also to research. In other words, I believe that even if the industrial military complex funds your research, you as a researcher should be able to publish the positive or negative result in a journal. And not only that, it should not be censored. In fact, if it's funded by taxpayer dollars, this is germane. I look at it as the Library of Alexandria for centralized science. And that will help guys like you and your co-host not to have an old fucker on like me to go through the reason why we went off the rails in centralized science, 100 years ago. And I think that there's going to be several countries in the world that actually take up this fight. And I do believe that this is something, at least in my view, in the United States we need, because since 1982, and we got Fauci, and then of everybody since then, we now have seen how laws, specifically the Bay Dole Act and the vaccine law and the FCC law, the things that I've already talked to you guys about, how they have been usurped and used to take away rights and affect the public health. And most people find this story incredibly interesting when I talk about it in podcast. I haven't really given a total historical perspective, kind of like I'm trying to give to you guys, because
you should probably be aware, like most of our audience is probably on board with all of this already, and probably very well aware that we have a corporatocracy as a government at this point. And I guess my concern is there a way back? Like, can you actually imagine a guy like Robert F. Kennedy even making his way into power in the face of such a behemoth of money and power?
I think I can envision him coming in now for the same reason why I agreed to go to talk to Rick to Huberman. I mean, I basically put a target on my back, just like Becker did by going out there. If you listen to the podcast, you'll hear the reason why. My nurse told me it's the time to go and talk about this stuff because of what happened in COVID. People are fed up with the bullshit that we're getting from centralized science, but it's not just centralized science. This is centralized institutions everywhere. It's at an all-time low. I mean, put on CNBC. Nobody fucking believes the Fed. Nobody believes what's going on with our money. There's a lot of people out there that don't understand inflation and don't understand why steaks cost, $100 now.
100%. But can some oppositional power like RFK actually get elected into a system that's fundamentally captured by these industrial interests?
Because
is that possible, or does the whole thing have to fall apart?
When's the last time you yourself, when you asked me this question, have read the preamble of the Constitution? How's it start?
Actually, we started a podcast where we're going through the Constitution line by line, and we actually never finished it, but we did get through the preamble, I think.
That's what I'm saying.
A couple months ago.
I actually do think it's possible. And I do think that it's more possible now than it's been at any other time in my life because of what we all just went through with COVID. And the bigger question that I have,
so it's like people have the power, in your opinion, if we're all pissed off enough. Okay.
Right. If we all that's part of the reason why I think this podcast is actually really important for people to put all the story together when they see how all the pieces fit. It's like the Tool song Schism. When you see where all the pieces fall apart and you see where they come together, you start to go, Jesus, we really can control some of this.
Yeah.
By just getting some control back on our own bodies. And where it really starts is with informed consent. So I'm okay. Like you said earlier, you're okay with, 3G, 4G, and 5G around you. Well, then we should be able to put signs up and say, in this podcast studio, you're going to be irradiated. We just want to make sure you're okay with that. So if you do develop a cancer somewhere down the road, that you don't hold us responsible. We're telling you that up front. I'm okay with that.
I mean, I'm not okay with it. I'm very disturbed by it, but I don't know how to function without it, right, in my profession and so forth. And I think a lot of people find themselves in that position. It's just like, I don't know how to function without a car, even though I know it's dangerous. That's why I keep bringing up that analogy. It's like,
well, but I think it's easy to just to push back on you. With Uber, it's easy. Let's talk about COVID. Let's talk about a positive thing with COVID. Now we all can do our jobs remotely. Have I changed the way I do neurosurgery from, say, 5 years ago to the way I'm doing it now? Absolutely. So I'm going to push back hard on you that we can't do it. Do I think we can use technology smartly? Yes. But remember that when I say that to you, then it comes down to you saying, okay, maybe I need to learn a little bit more about electrons, protons, and light, which is the reason why in the beginning of this podcast,
We're actually
push
writing a book on electrons, protons, and light right now. Just so you know, that's one of our favorite little pet projects. So yeah, we're way into it. The antenna model of light is essentially what we're working off of, but we approach it from a material science standpoint.
And that's fine, because that's effectively what it is. That's the actual best way to approach it. Becker decided to do it a different way. It's the molecular resonance model of actually how substrates in biochemistry are connected by light frequencies. And, when you see it yourself for the first time, and then you open up your biochemistry book and then you go, okay, now I know why NAD positive has an emission and absorption spectrum that it does. Oh, shit. And why flavins have the emission and absorption spectrum they do, and why DNA has it the way it does, or the hormone that, kind of made me famous on the internet, leptin. Why does it have 220 nanometer absorption spectrum when that type of light isn't present in terrestrial sunlight? It gets you to start to ask questions that you would have never asked, if you were sitting in the medical hall of Stanford listening to a biochemistry lecture, that, like you guys said.
Well, they call it the central dogma, right? They're like DNA, protein, this is
DNA,
how biology
RNA,
works.
All wrong.
DNA, RNA, protein, I'm sorry.
Right.
Sorry, as a biologist.
And that's
but
actually,
it sounds like your thesis is that there's another information network overlaid with this genetic business. There's something more that's equally important, and it involves essentially electromagnetics.
yeah, basically all DNA codes for is protein. And what did Albert Szent-Györgyi said? Proteins are the semiconductors in there. Then you got to ask yourself, okay, how could you have a control mechanism? You guys said you were material science people. Well, the way you bend an antenna actually tells you a lot about how it functions. Well, guess what? Doesn't that describe the primary and secondary bends on proteins? What controls that? It's actually DNA. But what controls the tertiary and quaternary bends? It's actually the redox chemistry inside the cell, which ties to the light of the environment, which gets us back to the Steve Jobs story. Well, the light that we now live under is no longer the light we're evolved to. So you begin to say, so is this the reason why most of the neurodegenerative diseases that Uncle Jack takes care of for in his clinic have problems? The answer is yes, it does. That's the big issue. And this perspective, this is not hokey pokey. We know about this. There's tons of papers out about it. But here's the problem, and I think why Rick wanted to bring me to Huberman. You need to bring all this together. Innovation isn't one paper. You have to have a breadth of science.
It's a whole body of work.
Correct. And you need to be able to cross disciplines. That's actually what Szent-Györgyi said in his 1941 paper to people, and that talk, and it stimulated Becker to actually go that next step. What I'm saying to both of you is that once you understand that we are beings of light, we're controlled by light, water, and magnetism, then it becomes incumbent upon you to go out and say, okay, are there books out there now that actually we can read about Jack's work? Like when I started this 20 years ago on the internet, there was no books out there. Like now I can tell you, go read this book on this, go read this book on that, go read this book on that. And then guess what? You want to have really interesting conversations? Come back to me after you read that book and you go, holy shit, I really didn't know what I was talking about that. And see, to me, that is the experience that I had 20 years ago when I realized just about everything I learned in centralized biology was incorrect. And because you realize it's incorrect, what happens then? Then you have to start to question the things you already believe. So now we're at the situation where you have to unlearn to relearn. Because guess what? Many of the things that you've learned in the past will block you from understanding how we really work, going down the road in the future. And that was the point why I said to you earlier, no, I don't want to get sidetracked by this and that. I want you to hear the whole history story so that when you put this together yourself, then you can jump down these rabbit holes of light. You want to learn about light? Go read Roland Van Wyck's book, Light Sculpting Life. You want to learn about water? The easiest way to learn about water is read Pollack's book.
Oh, we've had Pollack on the show twice.
But Pollack has mistakes. I'll be the first one to tell you.
Everybody has mistakes. Like
Right.
that's the thing about this, is that in order to figure out what's actually happening, you have to look at all of these different people's outputs and fit them together, knowing that nobody has the full story and knowing that you yourself will not be able to assemble the full story. What you're going to do is you're going to iterate on the previous generation. And what's fascinating about what we've been talking about all day today is that I feel like microbiologists are on this tick. This is something that, because when you put it into eukaryotic organisms and you start talking about the effect of EMF radiation on humans, you enter into this capitalist special interest state where you can't get to the clear information. But you look at microbiology, and there's this woman at Caltech, her name's Jackie Barton, and she's been studying how DNA acts as an electrical antenna for decades, and she's studying the way that bacterial repair proteins will centralize using electric currents in the DNA to the location of damage to then fix the damage. And and she's getting grants, and she has a whole career that's centered on this, that is happening on the sidelines because it manages to avoid that really difficult place of, hey, this is happening in humans too. This isn't just a bacterial thing.
Well, when you jump down the rabbit hole she's jumped down, and I'm going to explain this to your audience so they get it. Bacteria are prokaryotes. Prokaryotes release 5,000 times more light than eukaryotic cells. Remember the story I told you between cephalopods and us? You don't see the light in us. The same thing is true about bacteria. You can actually see it much easier there. But what's the jump to us? Well, the jump to us is our mitochondria is a stolen bacteria. Brings up Lynn Margulis's work. When you begin to realize that, then you go, wait a minute, is Jack saying that the mitochondria is an electromagnetic producer of light similar to the sun inside of every cell that actually is the composer that is directing all the boxcars in biochemistry to do this, and it works on redox signaling and light frequencies? And is that the reason why melanin controls the endogenous light story that's created inside us? Is that the reason why tryptophan, serotonin, melatonin, and leptin all have emission spectrums between 200 and 400 nanometer light that doesn't come from the sun? Because maybe we make the light inside of us.
Do we? Is that detectable?
Absolutely, with photomultipliers. And see, that was the big story that I released to Huberman, and he was stunned by this. That was the next step that Becker needed to go with. And I'm glad that you opened it up through the microbiome story, through the bacteria story, because you are absolutely correct. The link and the jump is going to be very easy for people, because guess what? What are my tribe called? They're called black swan mitochondriacs. Why? Because it turns out the genome that's most important inside of us is the mitochondrial genome, because that is where the photons come that control the hardware in the system, which is DNA and RNA. It's not the way Watson and Crick had it laid out. You just said earlier, the central theorem of biology is wrong, and it is, but let's talk about—
Let's say incomplete.
Well, I'm going to say wrong, because it is wrong. And here's the story. 99% of the NIH budget goes to study RNA and DNA. Only 1% goes to mitochondrial DNA. The world researcher who's the expert in mitochondrial DNA is Doug Wallace. He's actually said this publicly in multiple papers and talks that he's given. But the reason why we get cock-blocked in the eukaryotic organism is for what she just mentioned earlier. Because when you get to eukaryotes, all of a sudden, the people who pay for the studies know that you're going to jump right down Becker's rabbit hole. And they don't want you there. They don't want you knowing that light can replace drugs. And to show you just how powerful this is, I'm not going to give you a ton, but I'm going to give you this so you can fact check Uncle Jack. There is a disease that you probably know called Gilbert syndrome. It's related to an enzyme in the liver where it doesn't function as well. It's in the UDP system, and it's of no consequence in humans. But the more significant life-threatening part of this disease is called Crigler-Najjar syndrome. You'll be very surprised that a biophysicist named Irina Kosick and her husband have found that replacing violet and blue light inside the cell culture completely gets rid of this fatal disease. So just think about this for a minute. That light can completely fix a genetic problem. If that doesn't blow up the paradigm of Watson and Crick, of Darwin, of neo-Darwinists like Richard Dawkins, of big pharma, nothing else will. But guess what? I'm already telling you that paper is published. It's in the literature. The key is I want guys like you two to say, I got to pull this paper. I got to read this because this is unbelievable. And I did the same thing with Huberman. I told him about Luc Montagnier's work that you guys will probably appreciate because you told me that you're working on electrons, protons, and photons. The story was about water. And I told him that Montagnier wanted to prove that the guys at Nature were criminals because they basically caused a scientist named Jack Benevisti to kill himself because they tried to say that he was a quack. So after he won the Nobel Prize, he did the most amazing study. He actually took a bad, nasty virus, put it in water, then subtracted the DNA out by PCR, showed that it was not in there. Then he took the water, put the signal, the light signal that was in the water, put it over the internet, sent it from Italy to Paris, and was able to recapitulate the nucleic acids in Paris.
I've seen this, yeah. But nobody's been able to really reproduce it for some reason.
Yeah, it's only Montagnier's lab that's ever been able to do it.
But it's still out there. And the thing is, reproducibility is important. You know what the problem is? Have you ever looked down the rabbit hole why it's not been reproduced?
Well, there was a bunch of tests where they brought people in to be present for the reproduction, and when somebody was there and they were watching the guy do the work, it didn't work. And then when
you know the reason why, though, it hasn't been studied by other labs.
Well, because I think that people have a tendency of looking at stuff like that and being like, it's debunked, it's not worth studying.
We also just don't get funding to debunk people.
There you go. That is the real problem. And I will tell you that several people that worked with Montagnier, now that he's dead, have actually done the study, and it actually has been reproduced in different places. You know what the big issue is? Getting that research published.
We'd love to talk to these people. Because we're trying to put together basically a library of the ideas that are going to take over in the next 50 years.
Well, I think that in biology, the big idea is that quantum biology is here to stay, and quantum biology is going to knock down and take out a lot of dinosaur ideas that are present in molecular biology. I think fundamentally they'll be tied around light, water, and magnetism. But if you ask me, the most impressive part will be light. And the next key step is the guy mechanistically that you could have on your show because his son is still alive. Fritz Popp is the guy that was the physicist in the 50s and 60s who worked alongside of Becker and proved that every single living thing emits biophotons. Even Albert Szent-Györgyi knew through the biochemistry of the Krebs cycle that light was being emitted, but he had no way of categorizing what was really happening.
It's so interesting that you say that, actually, because I think that that's the frontier of knowledge right now, which is that the stuff that we're talking about is so far away and difficult to measure that up until this point, it's been almost impossible to verify. And so somebody can have an idea and propose it, but because there isn't the ability to put a photomultiplier tube inside of a body and measure that something is being emitted, it's easy to dismiss it. And now that there is, it's much harder to dismiss it. And so we're at this inflection point where suddenly for the first time, it's actually possible to point to the incontrovertible results and say, this is occurring. You must wrestle with it.
Well, I would tell you that the lab of Louis de la Salle in California actually put a harpoon in it almost 30 years ago, but most people don't realize it. Optogenetic research absolutely shows that light works inside of cells. I mean, we are now finding things out about neural tracts just using optogenetics that tells us that light is the basis of it. But you are correct that until we get the ability to put a photomultiplier adjacent to, say, POMC translation or to a mitochondria, or right adjacent to, say, where the TCA cycle occurs, so we can see what happens. The best that we have right now about cell cycle biology is the paper that I told Huberman about from 1923, where Alexander Gurwitch cut an onion.
The onion
Yeah.
paper, yeah.
Right. And you cannot have mitosis unless you get UV light stimulus to get you past that phase. When you realize just how basic that is, all of a sudden you begin to understand part of what the rest of the story that I told you about melanin is, and what melanin is functionally doing, and why melanin is the color that it is, why certain semiconductors are the color they are, and really what melanin is functionally doing. It's actually creating a kaleidoscope inside of us that control everything in us. And when you actually look fundamentally at a cell, we have 100,000 biochemical reactions in 1 second. The only thing, when you just think about it, that can control that is all the different spectral frequencies that go between 200 and 1100 nanometers. If you look at it, that number is like 10 to the 36 frequencies. So when you realize that, we are operating on really 1 octave of the electromagnetic spectrum, but it turns out that the chemistry that got innovated on this planet 3.8 billion years ago has been in this chemistry set for a long period of time, and it's being utilized. You know, back when the magnetosphere and the ionosphere were different, that's the reason why we see different frequencies. That's the reason why you've got the hole in the RF window that your friend talked about earlier. It's also the reason why we don't use anything between that RF hole until you get to about 250. And it turns out when you get to 250 to 600, that's the place where chlorophyll and hemoglobin work. And when you begin to see all this and you understand the story of evolution as told by biology, you begin to start to see a story unfold in front of you where now the Cambrian explosion makes sense. Like I told Huberman this multiple times, and I'll tell both of you this. If you truly understand the Cambrian explosion and the KT event, those two events absolutely blow huge holes in Darwin's theories of evolution. They are so counterintuitive to what Darwin has said, but if you go back and read the first iteration of Darwin's Origin of Species in 1859, he said of the two things that were tied to his idea, conditions of existence and natural selection, conditions of existence were more important. It turns out that's exactly not what history tells us in centralized biology. They've always focused on the mutation rate. And it turns out, if you look at the Cambrian explosion, literally overnight, you have 32 phyla show up in the fossil record. There's nothing about gradual or punctated evolution that's present in the evolutionary record.
Well, something crazy happened on Earth just before the Cambrian explosion. Like, you know about the
what
missing
it was?
piece of the Grand Canyon, right?
No, you know what it was. And if you don't know what it is, then you got to have an astrobiologist on. Our sun is a G-class star. G-class stars, when they get to mid-position life, they emit 10% more UV light. How do you like that?
There's like a chunk of... So the Grand Canyon is a stratigraphic record that goes back to before the Cambrian explosion. And there's 500 million years of rock that's missing just before the Cambrian explosion. And we were looking at this actually because a sudden amount of emission change from the sun would literally have to be so much solar radiation that it melted the surface of the Earth in order to ablate that much rock.
Well, or it could have been something else. I mean, you have to
something crazy happened, like
right.
and so I'm surprised that you say that it disproves Darwin, because if Darwin is like, yo, the environment is really important, then what it suggests is that the environment shifted dramatically.
Think about what you just said. That's not what you learned about Darwin. You learned.
I've read enough Darwin.
Natural selection. You learned that
we were kind of outcasts in the academy.
Yeah,
we were the people in the back of the room being like, excuse me.
I'm going to tell you the conditions of existence was more of a Lamarckian story than a Darwin story. I mean, that's what Huxley tried to bury, and I think Dawkins has done a pretty damn good job of getting people to believe that it's all RNA and DNA, because look at where centralized science is being funded. It's being funded on the nucleic acid side of things, not on the mitochondrial DNA thing. And then just think about, these other links. Realize who is married to Lynn Margulis when she came up with the idea of the Cambrian explosion and endosymbiosis.
Carl
Carl
Sagan.
Sagan, right? And the thing is, Carl Sagan, he knew that his wife was smart. She should have won a Nobel Prize for her work. But remember, she's a woman in STEM science. That's not going to happen because remember, it's a good old boys club. And I still always tell the good old boys that have won Nobel Prizes, just remember, a woman is the only one that's won 2 of them. And that's Madame Curie. We look, my whole point in this podcast is to get young people who are interested in science to ask better questions. That's really what this comes down to.
That is our point as well. Absolutely.
And I think when you do that, you will come back and realize the one accurate thing that's present in NASA's SETI program is life always revolves around 3 axes: light, water, and magnetism. And the way that it shows up on Earth, that's the chemistry lab that we have here to study it. I believe that light, water, magnetism can be fundamentally organized in a different way, that we could actually see life on another planet and not even realize that it's alive, but it is. And the way that we'll figure that out is when we put a photomultiplier on the planet and see if there's any light emissions coming from that planet that make absolutely no sense at all.
Have you read Thomas Gold's work?
Mm-hmm.
Because that's basically what he talks about, right? He's at the forefront of thinking about the nature of life and basically says that there is some possibility that there is life that we cannot recognize as life because we cannot conceive of its organizational structure that gives rise to the same sorts of processes that our organizational process structure gives rise to.
I think I agree with him, and I agree with you from a biologic perspective, but you have to realize that 20 years ago, I went off the reservation, and I am now much more of, how shall I say this, a physicist than a biologist. And when you understand that the atomic lattice in anything in a dissipative system basically is a flow meter for entropy, the key for looking at light, or I should say life forms anywhere, is actually looking how entropy flows and then seeing what light is tied to it. Because if you fundamentally understand circadian biology, what is its basis? Is actually every molecular clock is a flow meter for entropy in that system. And that means that we have all kinds of space-time conundrums that are in a cell, meaning that there's many worlds inside a cell. Each part has its own zip code. That means that each has its own solar system. And it turns out that melanin and different proteins in different parts of the cell are emitting and absorbing different frequencies. So that means that, for example, the neighborhood in and around cytochrome C oxidase is loaded with infrared A light because that's what its absorption spectrum is around. But the same thing is not true around cytochrome 2, where it's flavins and it's much more in the 400, 500 range. And then it's also not true at cytochrome 1 because that's where it's in the UVA range. And when
this is what I love about David Goodsell's work. Have you seen his drawings?
Mm-hmm. Yeah.
Right? Because before Goodsell, I think that there was the popular conception of the cell that's drawn on the surface of a biology textbook, which is just this bag of water that has a couple of things bobbing around in it. And Goodsell was the very first one to propose that, hey, hold on a second. If you actually think about what we know about the packing density of a cell, there is not a lot of free diffusion and free movement, and so it does exactly what you say. It creates these environments where there are specific conditions, and as things are moved on the transit highways through these different environments, different things are happening as they pass them by.
Yeah, it's like an amplifier. It has all these different knobs on it. So when something moves across time, it changes everything about the cell, and that's the reason why it's so difficult to understand. And, to try to bring this full circle back to what Szent-Györgyi said in 41, think about it. You actually gave centralized biology more credit by what you just said. that it's just a pitcher that's a bag of shit. I'm going to tell you that that's really not what biochemistry is. They took all the water out and they tried to study the boxcar chemicals, substrates, without the water in it. It turns out, guess what? The water is where the sea of electrons are that light innovates to create the electrons to delocalize in the cell. I mean, we have totally shit the bed when you actually really think about what biology is fundamentally done. I mean, when you parse out each one of these things, and when I hope you do go back and listen to the Huberman Rick podcast, because
Is
when
it
you
actually 10 hours?
yeah, well, the two parts are about 6 or 7.
Hold on, what the heck is Rick Rubin doing in the middle of this biology conversation? I mean, I like the Beastie
One of my
Boys and
patients.
everything.
He's actually
Okay.
one of my patients, and he had a medical problem that I helped him with 5 years ago, and he agreed.
He
to
just
talk
kind of got
about
into it at that point.
Well, he agreed to talk about it publicly because what I told him to do is actually tied to this story that I'm telling you guys about. It's about light, water, and magnetism, and his surgeon at Stanford and his good friend Peter Attia thought that what I told him was crazy talk. And then 3 months after, they had the surgery, Peter Attia came back and told Rick, he goes, that crazy neurosurgeon, he was on to something. The story around methylene blue is really a story about light. He goes, I didn't realize it. And
Does this tie into why you're not wearing a shirt right now, by the way? I feel like I should take my shirt off too.
No, the reason I wasn't wearing a shirt is because when we started this podcast, I was outside, and then something happened with the internet. I had to come inside.
Okay.
And unfortunately, I told you, I got a realtor in here taking pictures of shit because these lights never go on. I mean, if you look above me, I got infrared A and UV light on above me.
Nice.
That's beautiful.
So,
hey, can you tell us about the methylene blue story? I've seen this a little bit on Twitter. There's a lady who runs an organization called Remission Biome that's been doing methylene blue therapy, but I haven't had a chance to look into it yet.
it's a huge story. Again, one of those things I'm not going to get into with you here because I'm going to force you. I'm going to be that asshole to force you to listen and read and understand. But I will tell you this.
Will you come back and talk to us after we do that?
Yeah, we could do that. But what it effectively does, it absolutely allows you to delocalize electrons, and it also allows you to free up protons. So one of the things that you both be interested in, do you know where methylene blue, the story first came from? Do you know that it's a derivative of hydroxychloroquine? Did you know that?
Mm-mm.
I think our video just got banned from YouTube for mentioning that word.
I know. Well, but it's also the reason why, believe it or not, a lot of my members got told that this was something that you could use. And the interesting thing is, because we've been on the Albert Szent-Györgyi kick, he knew a lot about methylene blue because he was studying, remember, vitamin C. He used to call it hexuronic acid. And one of the things that he noticed is that the intermediates in the TCA cycle started to act linearly when you disrupted electron flow and you disrupted proton flow. And what he actually found out about vitamin C is that vitamin C really reestablished proton flow. And that's when we got the idea. Remember, he made the big error that the two big things in the TCA cycle were malic acid and fumaric acid. It turned out it was citric acid that was the big one, but it was because of the protons that transferred in. So when you have a loss of mitochondrial redox power between cytochrome 1 and oxygen, what effectively happens, the cycle becomes a linear biochemical reaction. And you can't make and reestablish NAD positive when you do that. So you fundamentally have a proton problem at cytochrome 1. Vitamin C can actually fix that, but so can methylene blue. And actually, Albert Szent-Györgyi was the guy that originally figured that out. And then that's what clued him on to this, that this was a cycle. And he did get parts of the story wrong, but he got enough of it right that in 37, they gave him the Nobel Prize. And then Krebs got everything right in 54 and got a Nobel for fixing the errors. And that very rarely happens in biology. I mean, we gave Peter Mitchell a Nobel Prize in 78 for chemoosmosis, but we've never fixed the problem by giving Gilbert Ling one to show that, actually biology isn't about ATP. It's actually solid state at a thermodynamic level. Hopefully someday that gets changed by, a young scientist who picks up the torch and proves that the chemoosmotic theory is a half truth and not, axiomatic.
We had a really interesting conversation with Nick Lane where we were talking about metabolism, and he was kind of in passing just mentioned the fact that the amount of protons in the inner membrane space doesn't actually add up to make the math work out. Like,
But
if you actually go and detect the number of protons.
I know. Do you know the reason why? And this is the most
No.
ironic. He's at UCL London.
Yep.
All he has to do is call up Jim L. Khalili, who's at Surrey University, and he'll find out the reason why. It goes we tunnel protons right through the outer mitochondrial membrane.
But you should still be able to detect roughly a snapshot of equivalent concentrations, no?
If you think that's the case, you don't understand enough about entanglement. That's not true. It's so fast. It's below. It's at the attosecond level.
I feel like we're missing some. I think that we're just missing something about the thing that we should be detecting, and we've used protons as a stand-in, but in reality, it's some kind of molecular motion that's happening inside of these proteins. Because if you look into, so I just looked up the structure of methylene blue, and the structure of methylene blue is the exact same structure, except it's substituted a little bit differently on the edge carbons as the phenazines that I was studying. So I basically spent 4.5 years thinking exclusively about the role of this molecule and how it plays into the redox systems of these bacteria and changes DNA expression. I hadn't seen it in context of obviously they play a function in respiratory support for bacteria, but I didn't realize that it was possible in humans as well. But
it is. But light controls this fundamentally, and that until we get those photomultipliers, and you understand, remember, the story about light. Look, I love Nick Lane's work, but Nick Lane absolutely is that guy that needs more physics in his life. He does focus in a lot on the astrophysics because he's interested in the Urey experiments and things like that. But he needs to sit down with Jim L. Khalili and really, really begin to parse out things, because if those two guys ever get together, we are going to have some very interesting experiments done in biology that will actually knock out some of the key features of what a mitochondria is doing. Because a mitochondria really is a kaleidoscope that creates endogenous light. That's effectively what it does through metabolism. And that light show is different in the different space-time continuums, even inside the mitochondria. People don't realize that inside the mitochondria, like inside the inner mitochondrial membrane, it's gel-like. And the reason it's gel-like is because it's piezo, flexo, and pyroelectric. It uses every single photonic ability in nonlinear optics that you can imagine, but nobody has actually put that together. The guys that are closest to it are the biophysicists, because they know about it.
Well, it's like so hard to study. Like, we're talking about stuff that is literally at the edge of our ability to detect well. Like, when I was doing my work, we were confronted by the fact that there wasn't a good probe for looking at redox conditions inside of a cell. Like,
I disagree with you, and I'm going to tell you the reason why, because I'm going to give you just an idea. All you have to do right now is something that Doug Wallace has perfected. Take a bunch of mitochondria out, put it on a dish, and then irradiate it with different frequencies of light, and then see what happens to the size and shape changes. You know what you'll find very quickly? You're going to find that you'll understand autophagy and apoptosis really well. If you go read some of my work where I make fun of Peter Attia and David Sabatini, Sabatini's done a lot of work on mTOR. You know what he's never actually tripped over? That mTOR has an emission and absorption spectrum of 380 nanometer light. So you know what that tells you? That UVA light is actually the anabolic switch inside of a cell. That's the reason why NAD positive is at cytochrome 1. And guess what? Everybody wants to give him the Nobel Prize because he's so damn close, but the only reason he got screwed is because of all that, Me Too crap that he got involved with in there.
Didn't he? Yeah, he had some like weird relationship with somebody that got upset with him.
But he's really good friends with Huberman. He's good friends with Peter Attia, and Peter Attia thinks he's a god. And I just sit back and I go, dude, he's just like other people. They got part of the story. They don't have it all right. And until we get to that core level, it's not the biochemistry that's important. It's actually the light that controls the biochemistry That is the key. That's why I always want to talk about Albert Szent-Györgyi, because this guy was fucking brilliant. He was the guy that knew that what he won the Nobel Prize for was not the key part of the story, but it was so important in 1930s when biochemistry was being laid out that it blew the Nobel committee away. In fact, most people don't even know this. There was a big fight about his Nobel Prize. They wanted to make him share it with somebody else, but people on the Nobel committee said no. His work between vitamin C and the TCA cycle was so important that he should not be made to share it. And he spent the rest of his life. This is one scientist that I have to tell you, I have a huge amount of respect for. He spent the rest of his life actually trying to prove himself wrong. The only story that I can think of in science that is kind of amazing like this is the United States federal government, when Philip Lenard, who was, a Nazi, basically was able to cockblock Einstein's Nobel Prize for the photoelectric effect for almost 20 years, just because he was a Jew. So what did the United States do? They hired George Millikan to prove Einstein wrong. And don't you think that George Millikan proved that experimentally that the thought experiments that Einstein did in 1905 to come up with the idea of the photoelectric effect were in fact true? So what did centralized science do? They gave Millikan the Nobel Prize before they gave it to Einstein the next year. And to me, when you hear that story, it just makes you realize just how ass backwards we have things. And it also points out that Einstein was such a good thinker that he was able to come up with thought experiments that turned out to be true when they were experimentally proven. And this is one of the things that I actually got into with Huberman that got cut. I actually said to him, I said, this is one of the big problems in biology, that we don't have quantum biologists that are theoreticians, and we should, because those are the people that are going to move the needle the most. We focus in on people that like to do the experiments and think that they're the be all end all. And that's the reason I pushed back on, your co-host earlier about the Luc Montagnier story. The fact that he was able to show mechanistically that there's a connection between light and water and that it can be sent over a network. Let me just tell you something. That alone absolutely needs to be studied experimentally, but it opens a can of worms where we may not have the photomultipliers that can do a lot of this stuff, but there's a lot of things we can do. And like one of the ideas that I've come up with is just irradiating different parts of the cell, like the endoplasmic reticulum, the water in a cell. I mean, that's kind of what Pollack has done. But to me, Pollack hasn't gone as far as, Martin Chaplin. He didn't go as far as Del Giusse and Praparda. Some of the water researchers that are out there now are going way past that. Like, for example, I have contacted Gerry multiple times. I said, you need to redo all your experiments with deuterium depleted water. Why? Because that's the water that a mitochondria makes. It doesn't make water that has 155 parts per million. And I said, do you realize that if you study water that's just what I would call water from the hydrology cycle, that you really don't understand what mitochondria are functionally doing? And he looked at me like I was crazy. I said, do you realize that mitochondria makes water that has a dielectric constant that's 160, that the water that most other things are made of in life have a dielectric constant of 78. So it's double. You're going to tell me that that is not going to lead to a massive effect when you know that everything in the cell is quantum mechanical? I mean, the dielectric constant actually directly tells you something about semiconduction. It tells you about, semiconductive circuits. I mean, but the problem is Gerry doesn't understand the physics. And when I say something like this to a guy like that, he looks at me and the first thing he says, well, I need money to do this stuff. I say, dude, you don't need money. I mean, give me a fucking break. All you need to do is to get deuterium depleted water, which you can buy for $20. Do the same experiment you did with, Naphion, and put light on it and see what the difference is. See what you find then. And if the difference is bigger, then you need to do really big studies and spend a lot of money. But the basic experiment that he needs to do is a third grade experiment, because guess what? Most people in centralized biology don't know that mitochondria only make deuterium depleted water. Why is it that a mitochondria is racist against deuterium but not against protium? I can tell you the reason why. Physics. T equals mc squared. Why? Because anything that's got double the atomic mass and it's got a different magnetic moment is going to be handled differently by the electromagnetic force. I mean, whose rule is that? That's Einstein's rule. E equals mc squared. It's not Jack Kruse's rule. These ideas are absolutely foundational to cornerstone science, but they're not getting done. And the reason they're not getting done, guys, is because people are not asking the easy, basic questions. We want to ask about the bullshit, that's out there that is really got no effect. Like when I see somebody like, Rhonda Patrick talk about, what's his name? The asshole from Harvard that's trying to sell everybody on the idea of NAD positive supplements. This is
Was it
absolute.
Sinclair?
Yeah, I mean, it's absolute madness. I mean, this is not stuff that's going to move the needle. The stuff that's going to move the needle is the foundational stuff that we're talking about here. About
Sinclair
light.
does look really good, so whatever he's doing is working.
Well, I'm definitely not a fan. I'm going to tell you. I think he's one of. I look at him as the J.P. Morgan of centralized science.
Interesting. I mean, we haven't talked to him. I've wanted to talk to him. He's hard to reach. I've not been super amazed by his work because I think that it is very much in the paradigm of there's a molecule, the molecule is what you need, and as long as you supplement the molecule or go down this very conventional pathway, that's going to be the solution. But
his classmate, if I'm not mistaken, or maybe no, it was Peter Attia's classmate, Rabinowitz, did 3 papers in I think they published in Nature that all showed that Sinclair's work is total bullshit. Then there's another PhD researcher who you should have on the show, Charles Bremer. Bremer is absolutely nuclear on Sinclair's work. I mean, in fact, he just wrote an op-ed, I think, on Sinclair's last paper. He's on Twitter. You guys could follow him. I guarantee you he'd come on this podcast. But he feels the same way I do about Sinclair. Like the best paper that Sinclair ever wrote, in my opinion, is this 2013 study in Cell and Molecular Biology about pseudohypoxia, NAD positive, and oxygen. Basically, that anytime NAD drops, redox drops, and aging is a problem. I totally agree with that. Why? Because it totally fits with what Doug Loss has found in his work on mitochondrial DNA. So in other words, we have corroboration there. The problem is he takes that research and says, okay, this is where resveratrol and the sirtuins come in. And then you realize that he sold that whole line of bullshit to GlaxoSmithKline for $400 million and robbed them with his buddy Lenny Guarente. Not that I'm bummed out that he robbed Big Pharma. I'm all about robbing Big Pharma. But the point that I'm trying to say is that when we're scientists and we're clinicians, we are relying on the people who are doing the science so that we can help the public health. The reason why we spend so much money and we get no return on equity in the public's health is because most of the shit we study is worthless, which brings me back to the story of why I told you what I said to Gerry, that if we're going to study water fundamentally, we need to study the water the mitochondria makes. Everybody forgets that photosynthesis is reversed by oxidative metabolism. That's functionally what the story of the Cambrian explosion is that we finally got a way to reverse photosynthesis. And when we did that, what did we do? We created CO2, which is a paramagnetic gas, and then we get H2O. But the H2O we got is not the H2O from the hydrology cycle. It's actually deuterium depleted from the mitochondria. And that, to date, with all the great science we know, has never been studied the way it should be studied. And because of that, many of the things that you guys said at the beginning of this podcast 2.5 hours ago, why are we at the edge and why don't we know more? I'm trying to tell you, these are the reasons why. These are the reasons why we know really cool things, but they haven't been studied appropriately because people don't understand how disjointed science is because of who's funding it and financing it.
Man, it's really interesting. So my advisor, he's a water physicist in grad school, and we're still pretty close. And after the Gerry Pollack interview, I was talking with him over Zoom, and he started laying into the dielectrics of Pollack's model. And I didn't totally follow everything he was saying, I'm going to be honest, but I'm excited to go back and check out this deuterium depleted situation and see how that might affect things, because
Oh, it's huge.
I thought that was really interesting.
Just go in the periodic table. I mean, you can do a basic hack yourself right here. Realize that deuterium has double the atomic mass because it's got a proton on it. But here's the big one, especially when we're talking about light. If you accept even 5% of what I've already told you, realize that the quantum spin number of deuterium is +1. You know what it is of protium? It's a half. So you know what that means? The electromagnetic force operates totally differently with deuterium water versus regular water. Like, this is like basic physics. I mean, this is the reason why heavy water was used in the Manhattan Project and why regular water wasn't used. So
it's got like more angular momentum, you figure?
Yes, absolutely. And that
so it must make it more.
It's got a huge kinetic isotope effect. No, it's got a huge kinetic isotope effect. Think about what I just told you about St. George.
What a kinetic isotope effect is.
I'm going to explain it to you right now.
Okay.
Guess what? You have a cycle, TCA cycle. See what I'm doing? It's got to keep going, keep going, keep going. Kinetic isotope effect means that one deuterium affects the movement of 96 hydrogens. What do you think happens when that happens? It goes linear. That's the reason why methylene blue works in that situation, because what does it do? Pulls the deuterium out of the matrix so that you go back to this. Guess what is loaded with deuterium? Let's bring this now home to all the internet bro science guys that you probably shouldn't have on your show. That's the reason why seed oils are bad, because they're loaded with deuterium. What parses deuterium out in nature? Again, we're back to the decentralized network. Now you're going to see some of Jack Kruse's magic come out. Photosynthesis depletes us of deuterium. So guess what? C3 and C4 grasses have different levels of deuterium in the matrix. And then who eats those grasses? The things that we eat. So what do you think? All those crazy things that you learned in biology class, like all those enzymatic steps in glycolysis, the PPP, the TCA cycle, have you ever stopped and asked yourself a question? Why is this driving me crazy as a PhD or a medical student? Why is nature doing all this? The answer is very simple. She's trying to get rid of deuterium. That is the whole fucking point. And the reason why, because if you don't get rid of deuterium, you change the atomic lattice inside the cell, which changes what? The conditions of existence. It changes the flow meter of entropy in the zip code inside the cell. That means that nothing works in a dissipative state any longer.
So do vegetarians have higher levels of deuterium if it comes from grasses?
Of course. That's the reason why saturated fat diets do better. This is the reason why ketogenic diets help people with seizures and brain tumors. What do you know about saturated fats?
I like them a lot.
Right, you should. But you know what I did when I figured all this stuff out? I would go into my MRI machine where before I would do a brain tumor, I would MRI a coconut or an egg. And guess what I found? I found that those things are deuterium depleted by nature. How do you like that? Could that be the reason, the fundamental reason why all of you know this stuff? But see, you don't know the biophysics enough to understand how a simple little change in the atomic isotope inside the most important organelle in your body could change every bit of redox signaling in it. Instead, we have idiots like fucking Sinclair that want to sell you NAD positive.
I have an inherent distrust of anybody whose research bottoms out by this supplement. Like, I have a really hard time with that because I feel like that's somehow antithetical to the entire process, because the goal is to be able to accumulate knowledge, share it, and when somebody has a fundamental stake in the financial success of their research, it creates a tension that I don't like, because
that's
it's the exact same.
Sinclair, right? It's the Upton Sinclair story.
Yeah, exactly.
Back there again. And I'm glad you said that, because that is my fundamental problem with centralized science. I'm going to tell you that at all levels, they're conflicted. Like one of the things I told Huberman in the podcast, I said, one of the problems that I have with all nutrition studies is, remember, all of it is done under lab requirements with non-native EMF fields and blue light. And what do we know now? We know that putting any mammal in blue light raises AMPK pathway, blood glucose, and insulin. How do we know that? We learned that from Becker, and it was recapitulated by Nora Volkow in 2011. But when you know that, how can you tell me you know anything about nutrition? Because you don't. And
not much is apparent.
Well, it's not, though. You say it's apparent. Maybe apparent to you, but you know who it's not apparent to? Guys like Sinclair, guys like Sabatini, guys like Peter Attia. Like Peter Attia, to this day, he just wrote a book that's a New York Times bestseller that tells people how to live, and he exercises in a fucking blue lit gym every day.
I mean, it's interesting because Shiloh is particularly sensitive to light. I'm not, for whatever reason, but my parents.
I guarantee you are. You just don't think you are.
But you grew up in a house that was just full of blue light. I mean, I go to Nastia's parents' house, like we were just down there in the Bay Area, and it's just like I'll just in the evening, especially I'll just have the lights, turned down, and somebody walks in the room, just turns on the floodlights, and I'm just like,
yeah,
it just really hurts me for whatever reason. And I've always been this way. I actually cultivate my lights like most people probably cultivate their gardens. Like I am very obsessive about the lighting in our house and so forth. I don't know. I just intuitively feel that way. It causes headaches and everything else.
Part of the reason why when you asked me earlier, Jack, do you have headphones? I'm like, if you know anything about me, there's no fucking chance I'm putting headphones anywhere on my ear because you have a melanin sheet between the environment and your eighth nerve. That is the stupidest fucking thing you could ever do. And people who put Steve Jobs AirPods in there, dumber fucks. That's the fastest way to destroy that melanin sheet. That's a great way to get tinnitus. It's a great way to get hearing loss. It's also a great way to get this new disease that nobody seems to know about called misophonia. Guess what? Do I believe many of the diseases that are in your guys' neck of the woods, meaning your cohort, people that wear that stuff, like ADHD, a lot of the neuropsychiatric conditions are all tied to that. Yeah. Why are kids killing themselves at record rates when I was your age? That was the furthest thing from anybody's mind. I played outside all the time.
Do you know that suicide rates in children fall during the summer by half or something?
Of course I know that. But you know what you say it to me incredulously and I'm like, girlfriend, do you know who you're talking to?
At this point.
I've been on this for 20 years. And remember, when I started this, there was very few papers, there was very few books out there. I actually went and had people in medical libraries translate Norwegian and Russian data that Becker talked about in the books that I told you to go read. It cost me over $100,000 to translate those papers, to figure this shit out. Now, you are able to go and read Marino's book. You're able to go and read all of Becker's book. You're able to go read Pollack's book. You can read Roland Van Wyck's book that actually talks about all the Russian experiments that I translated. It's look, I'm not infuriated by it because it's going to help someone who's young and curious like you are, but I need you to really understand this history lesson. You don't know the shoes that I've walked in. I have been an outcast for 20 years. Why? Because I think Becker is the smartest fucking guy that doesn't have a Nobel Prize. And I think he got wise because he was so curious because of Albert Szent-Györgyi's talk in 1941. That is the reason why I really wanted you to understand the history lesson. It's also the reason why Rick wanted me to go out and talk to Huberman, because this historical perspective is really, really important because I want people to begin to ask the right questions. I fundamentally believe that science is moved not by funerals, like what Max Planck said. That was true, I think, back then. And it may even be true in biology now, because there's a lot of people that we would be better off if they died because of their perspectives being so bad. But I really believe that it's the young people that remain so curious that they say, you know what, I am going to do this experiment. It sounds so counterintuitive, but I'm going to try this out. I'm going to find out what it is. Like I just had, when I was in El Salvador talking to a young 18-year-old, she told me that she wanted to be a neurosurgeon. I told her, before you're a neurosurgeon, I want you to go study with Jim El-Khalili and Dr. Avila, who's a biophysicist over at Surrey. I said, you go do a year or two of research with them, come back, and I'll teach you how to be a neurosurgeon in 1 year. Because that's all it takes. I can teach a monkey how to do neurosurgery. But you know what I can't teach? I can't teach a neurosurgeon to understand that most of the shit they learned in medical training is hogwash. I need you to learn how we really work. I need you to understand how all 5 senses have melanin between you and the environment, and how all those tracks all go to the thalamus, and why the thalamus creates the alpha wave, and why the alpha wave links to the global network between the sun and the moon.
Have you
And
written all
why?
this down somewhere?
Hell yeah. It's on my Patreon blog. Why do you think people want to talk to me? I've been writing this for 20 years. Every time I write a blog, people's heads go poof. That's the coolest part of the story with Rick. Rick is not a scientist. You guys know who he is. He's a music producer. And he always tells people, he goes, look, he goes, I know Jack is smart. He goes, I don't want to learn the science. He goes, I just want Jack to tell me what to do. He goes, magically, when he tells me what to do, I do better.
Mm.
And he's friends with Peter Addy. And he goes, Peter wants to tell me all about the science. He goes, I don't give a shit about it. He goes, but I can tell you this. I know that Jack's got more right than him. He goes, but I still keep them close. And that was really illuminating, I think, to Huberman, because Huberman was like, Huberman's got a lot of friends who are neurosurgeons, people that he reveres, because he thinks, neurosurgeons are brilliant people. And I have a different take on that. I don't think anybody's brilliant. If everybody was brilliant in centralized medicine right now, or centralized healthcare, why are all our patients sicker than fuck? We're doing something wrong. And until we embrace the suck and realize that our patients are sick because our paradigm is wrong, we're looking in the wrong genome. We're not looking at the mitochondria of the genome. We're not understanding the physics of organisms. We don't understand how the atomic lattice links to entropy, and how entropy links to the circadian mechanism, and why melanin is between every single sense and the thalamus, and why the thalamus makes the 7.83 alpha wave. Why are these things there? Like, ask those basic questions. Realize that when you study the mechanism of what the thalamus is doing and the DC electric current that it makes between sleep and day, which is what Becker did, you sit down and go, Jesus Christ, if you look at the science, basically we have an FM radio antenna that goes between our central retinal pathways on our thalamus and all of our senses. And that FM radio station is actually what builds the alpha wave in our thalamus. And that has huge effects on the CSF that's around the brain. Does this make sense now why the brain has CSF on the outside? Does it make sense why the brain's blood vessels come in from outside? That is radically different than what happens in the kidney. Of course it does. No duh. But you're never going to get that when you go through Stanford Medical School. They're never going to tell you why the anatomy of the brain is different compared to every other organ in the body, because they don't understand it's a quantum computer. It's an electromagnetic antenna that's loaded with more mitochondria, filled with more water, creates more water than anything in your body that's deuterium depleted. That's the story.
Is the alpha wave signal in the thalamus different in people that have sensory defects?
Of course. I mean, the perfect example of that is people with autism. Think about what autism functionally is. It's a neuromelanin migration problem. That is a transgenerational problem that happens between the mother and the father. And most people don't even know this, but Siamese cats. I just wrote a blog about autism for a person at Google who asked me to do it. Siamese cats lay this out. If you go and look at all Siamese cats, you'll notice they all have blue eyes. Okay. And the funny thing is they have a lot of problems with their eyes, meaning sometimes they get turned in. They're all kind of crazy. The reason for that, it turns out that the melanin that's in their neural tracts is really abnormal. So it affects migration. Most people don't even know, because they haven't read a goddamn embryology book in 50 years, that actually melanin controls migratory patterns in neuroectoderm. And it turns out it does this through vitamin A. Vitamin A has huge effects. Well, guess what? The non-visual photoreceptor system in the brain, which melanin is part of, so is cholesterol, so is melanopsin, so is neuropsin. These are all the things I talked to Huberman about. He should know this. In humans, it's a weak covalent bond to vitamin A. So the reason why blue light is really bad, it liberates vitamin A, and what does that do? That destroys melanin sheets anywhere they are in your body. What happens then? You get neuromigratory pattern problems. This is the reason why kids with autism actually show what I call a regressive evolution. They go back to being like a monkey who can't talk because the melanin's not there. Just think about when a baby comes out of your vagina Can the baby talk and walk and run around? The answer is no. Why? Because its neuromelanin's not developed in its head yet. Well, guess what? That system is broken in kids with autism in their sensory relays. And guess what? Is that all those studies done in the ENT literature for the calyx of hand, or held, I should say, or is all that stuff done in the central retinal pathways? Yeah, it's all there, but nobody's putting it together. But guess what? Why I've had a Siamese cat ever since I'm 15 or 20 years old? Because I learned about melanin a long time ago. I've been fascinated by it since I'm a little boy, but I didn't know what melanin really did until I got to be about 40 years old. Then when I figured it out, I'm like, this is the fucking greatest story never told. And when did I first tell that story? In total, of really what it means, I told it to Rick Rubin and Huberman in 10 hours and left both of their jaws on the ground. This story is the greatest story ever told. Anybody who's interested in biology, anybody who's interested in evolution, has a duty to themselves to listen to it. This will shake your foundations, but I promise you this, and I swear on my life that I'm right about this. You will become a much more curious mammal after you listen to this and listen to this perspective. You will become better interviewers because the future scientists that you're going to have on after me, you're going to say, wait a minute, we need to put this through this lens. What is the effect of this on endogenous light production? How does that change the hydrogen bonding network in water? And then how does that change the paramagnetism of free radical signaling in us? Is that fundamentally what free radicals are all about? It's about magnetic flux? Of course it is. Anything that makes an EPR signal is a free radical because it has an unpaired electron. Oh shit, look at that. We're back to that goddamn physics story again. Look, this is a fabulous story. And I tried to tell you that I got tuned into this fabulous story through Albert Szent-Györgyi and Becker. And I jumped down this rabbit hole and I don't want to come out of it. I want to blow up the paradigm that created me.
Yeah, it sounds like we got a lot of reading to do. We'll definitely check out that podcast and get some notes together. Maybe come back down.
I mean, I think that we've been on this trip already. This is something that we talked to Pollack, we talked to Claridge, we've looked into biophotons. A lot of our audience is fascinated by it. And so it's really gratifying to have you here.
And we experience it in our daily lives, right? We know that there's something missing. We're always trying to tune our environments, even subconsciously.
And this philosophical idea of how the organism is shaped by the environment in a way that isn't clearly laid out in the textbooks, where evolution is natural selection and mutation rates rather than an iterative response to everything that's around you that feeds back onto the past and the future in a very discrete and yet nebulous way, is apparent. And so we know that as we change our environment, as we change the material flux through our bodies, we are changing who we are. And it's obvious that we don't yet understand the effects of modernity on our lives. Like right now, we're spending a lot of time because we're writing this book about light and gravity, like Shiloh said. And so we're trying to focus on this question of what happened to us as scientific people when we lost the idea of the mediator, because we had the idea that light was due to luminiferous ether. We couldn't find the ether. In the aftermath of that, we had Einstein and relativity and quantum mechanics. And there is a sense of light being an immaterial thing that has mysterious properties, but that none of those properties feed back onto our bodies because we don't think of ourselves as being part of the material that light travels through and generates light. And so we have to understand that.
When you say that to me, I have to tell you what's going through my mind, because I could probably talk about this for another hour. I so disagree with that. Like, every time I think about the supercosmatic nucleus, I can't get away from general relativity, gravitational lensing, and light. That's all I think about. Why? Because I know that all Garmin devices work 38 microseconds faster up when They're around in satellites so that you can find a Starbucks in San Francisco. But what you seem not to know is that the optical lattice clock in your suprachiasmatic nucleus also runs faster than every other molecular clock distal to it. And that's the reason why evolution put your master clock in the top of your head, in your eye, where the light comes in the best, and why it's not anywhere else. Because guess what? It is the key entropy measure of everything else in the body. Like general and special relativity are happening every single moment that you've been on this podcast with me. And it's my job to make sure that before you write that book, you learn a lot more about the eye clock and how it really works in correlation to the molecular clocks distal to it in the tissues, and how that links to melatonin, and how that links to endogenous light production, how it links to melanin. Because when you learn that, then I'll feel like me coming on this podcast was well worth it. Because that's how we work. We are creatures of light. I said this to Rick, and I said it to you, and I'm going to say it to you too. In the Bible, Genesis 1:1 to 1:15, it was absolutely correct. You know what the problem is? God didn't tell us the recipe. I feel like I was put on this planet to talk about the damn recipe. Okay? And I'm still tearing it apart. But I can tell you, I'm way far down this rabbit hole, 20 years down this rabbit hole. And when someone tells me, no, I don't think I can, or I don't think it's out there, I'm that guy that until they put me in a box and throw dirt on me or burn me, I'm not going to stop. And I'm going to keep calling out bullshit, especially centralized bullshit, when I see it.
So what's the... Oh, go ahead.
No, right on. I was just going to say right on.
Yeah, I think we're in the same boat as you. What do you want us to learn about this clock?
Everything, because it is actually the key to understanding why the return on equity of public health has been what it is. Turns out, I just gave a huge talk in El Salvador to a group of entrepreneurs. And in that talk, I let probably too much out of the box than I should have. But I told them that having CRISPR technology and doing genetic manipulation at the RNA and DNA level isn't where you should spend your money, because what you need to understand is all the GWAS studies, everything shows that circadian biology controls everything. And what people keep forgetting is that circadian biology is a post-translational event. What does that mean? It means DNA is designed to be stable. And the only way it's stable is when the light environment matches the decentralized network that is the Earth and the sun and the moon. Circadian biology cannot happen without those three celestial bodies. Those three celestial bodies have a specific molecular frequency and a mechanism of action that nature dictates. When you are the silly talking monkey on the planet that uses its frontal lobes by breaking its melanin down to create noradrenaline and dopamine, and you break some of those laws, magically, you start to see the process happen in front of you. And no one in centralized science has realized that circadian biology all is post-translational. What does that mean? That is a huge story of why Doug Wallace is right and why guys like Craig Ventnor, Sinclair, Aubrey de Grey are wrong. Even Nick Lane. And Nick Lane should be the guy that's on top of the heap. Why? Because he's a fucking expert in mitochondria. But what he doesn't seem to understand is that mitochondria's three key functions are creating water, CO2, and light. And until he understands fundamentally what those things are doing and how light post-translationally changes the game, it changes how the hardware is expressed. That is the story. That's circadian clock in your eye and the input to it via the central retinal pathway that has what between it? A huge melanin sheet called the RPE. And that RPE goes where? Goes directly to the SCN. Where else does it go? Directly to the thalamus via the habenular nucleus with no synapses. You need to see what I see, younger lady. And when you see it for yourself, you're going to get a really big appreciation for just how biology truly is in a fundamental science.
Dude, I spent hours in my PI's office, and he bore this with the patience of a saint. But I was like, I cannot finish my PhD until we know what charge means. Because you want me to write in my PhD that we're moving charges around on these phenazines, and I don't know what that means. And then I went to the physicists because he was like, the physicists know this is not a biological problem. And the physicists were like, we have the equations for it, but it turned out that nobody actually had an explanation for what charge was. And so the goal of the book that we're writing right now is literally just fundamental physics of being able to say, okay, what are the potential material models that fall out of the math that let us think about physics in the same way that we think about biology? Because we think about biology as a fundamental science because it's so molecular. We're like, there's stuff that is moving around and we can point to it and we can see where it goes and we can see what it does. But physics, at the very base of it, is mathematical. And so the only people that have a good sense of physics are the people that are super, super good at abstract mathematics. And we're like, let's take those abstract mathematics and think about what that could actually look like so that everybody can have a visual picture. So when you talk about the stuff that light is doing, we can actually think about it in context of making biology a fundamental science that includes in it the same material level of description that physics has available to it.
I feel bad for you that you have a PI that is that myopic. I'm going to tell you.
He was a good guy. He knew.
I'm going to tell you,
it's pretty common. I think most biologists would probably kick the question of charge to a physicist.
Yeah,
right?
I think that he was like, we don't do this.
Charge is actually very simple, I think, to understand when you're a biologist. But where it gets complex is when you think about the implications of what I'm about to tell you. Charge is the amount and movement of electrons and protons in the system. And it turns out, if you look at inner mitochondrial membrane, the wiring diagram from NAD to oxygen, it goes from about negative 400 millivolts to negative 200. If you stay between negative 400 and 200, because you have more net negative charge in your body, what does that mean? More electrons, you will be healthy. If you have outside that range, that means by definition, on a pH scale, logarithmically, you have more protons in there. When do you get really sick? When the protons that you have are many more deuterium, especially at the mitochondrial level. Why? Because deuterium lowers the thermodynamics, and that changes the size and shape of things in the mitochondria. When you begin to understand that charge, thermodynamically links directly to size and shape and morphology changes in the mitochondria. You know that the mitochondria, as Nick Lane has said, has a 30 million volt charge on the inner mitochondrial membrane because it's only 6 angstroms big. Then you start to go, okay, what is the link between classical biology, classical physics, and the quantum level? It's Avogadro's number. That's it. When you come down to that and you realize that that is the link between mathematics and what you're talking about. And the reason you fundamentally don't understand this is because nobody has made this foundational argument to you. It's about the net negative charges that you collect in the way you live your life and the positive charges you get. And then within the positive range, because remember, protons are not a fundamental particle. They're made out of quarks. That's part of the reason why understanding deuterium and protium is a big thing. Just be thankful that we don't use tritium because it would make it more complicated. But when you begin to understand the true binary code in biology is the difference between protium and deuterium, and understand that light is the thing that's moving electrons around to do some of the quantum mechanical things that make, quantum biologists' head spin, then you'll begin to understand charge very, very differently. Why? Because what did Ilya Prigogine, a non-equilibrium physicist, say about charge when he won his Nobel Prize in 1977? That it appears to me that everything that alive is a dissipative structure. What does that mean to your PI? What should he have told you or she told you? That a dissipative structure stays far from equilibrium. You're a biologist. You know that we learn everything about equilibrium when it comes to biochemistry. It turns out it's exactly the opposite. The only time we're at equilibrium is where we have rigor mortis. But when we are dissipative and we are storing a negative charge at the electronic and vibrational level, again, we're back to Szent-Györgyi, the initial insight that he had, that is how you stay healthy. And every single chemical in your body that turns out to be important, guess what it does? Tends to be in and around light, especially UV light, infrared A light, and electrons, and the movement and collection of it. That's functionally why water in us is deuterium depleted. Why? Because it's in a better electromagnetic capacitor when deuterium's not in it. You can bury more light at the electronic and vibrational level of water when deuterium's not present in it.
Tie this back to Avogadro's number for me.
Well, just think about what Avogadro's number means.
Well, it's the number of molecules in a mole.
Correct. So guess what we're talking about? The number of molecules in a mole, doesn't that link to the number of electrons and protons within the system? That's exactly what quantum entanglement links to. So I want you to understand what quantum entanglement means. Quantum entanglement means that your condensed matter state means that you have many more electrons or protons in there. When we're talking about the proton side, we're talking about a Bose-Einstein condensate. That's actually some of the stuff that happens in CSF.
You're basically saying that, okay, so you're basically saying that because deuterium is heavier, there's fewer molecules per unit.
Not fewer, it controls more of the behavior of H+.
But there's fewer molecules in a mole
control.
Of deuterium.
Yeah, but biology can't have control. What I'm saying is deuterium affects Avogadro's number because effectively the amount of protons that can move inside a cell are limited. Protons need to be freely flowing. Effectively, what are mitochondria? They're hydrogen bomb engines. That's what they are. They work by Carnot's theorem. They need to have free flow in them.
And the deuterium stops the flow.
You got it.
I mean, we'll go through the reading list. We will figure more of this stuff out, and we'll have you back and we'll talk about water next time.
All right.
That sounds like a plan, yeah.
Hopefully you enjoyed the renting a couple hours through Uncle Jack's brain.
Oh, man, this has been a riot, actually. I really enjoyed talking to you. Yeah, thanks for stopping by.
And for bearing with us during the technical difficulties.
Oh, no problem. Anytime.
Thank you so much, Jack.
Take care. Bye-bye.
Right. Bye, everybody.